Thankfully, our 4.5 billion-year-old parent star didn't use any makeup to fix its skin tone before this photo shoot, and now we can study its surface in great detail. This iconic image was taken in March 2022. NASA wanted to gain a better understanding of solar behavior and its impact on life on Earth, and the future of our space technologies, of course. To do so, they launched the Solar Dynamics Observatory Satellite, or SDO, mission in February 2010. This legendary photo shoot happened 12 years later, when SDO was halfway between the Earth and the Sun. Scientists had to assemble 25 individual images like a puzzle, so the final image contains 83 million pixels. Yeah, the resolution is about 10 times better than your fancy 4K TV screen. Look at this amazing cookie-like pattern. Typically, the bright surface of the Sun overshadows it when we observe the star from Earth. Thankfully, NASA explored the light beyond the visible range, which allowed them to discover some invisible details of the Sun's face. When you adjust your selfie with filters and effects, you can end up with completely different portraits, highlighting different spots of your face, even those you didn't know existed. The same principle works here. All these plasma balls are the same photo of the Sun, captured at different electromagnetic wavelengths. The revealed spots and patterns can help us understand events happening inside the Sun's skin a little better. At the speed of light is supposed to mean super quick, but this rose gold ray caressing your cheek at dawn has come a long way and is incredibly old in human terms. Photons generated by the Sun's core take between 10,000 to 170,000 years to travel through the star's atmosphere, and then around 8 minutes more to reach Earth. So let's explore what's taking them so long. Our tour begins with the upper layer of the Sun's atmosphere. Remember solar deities in movies and theater plays? They often wear luxurious crowns with golden rays. Well, the real Sun does wear a fancy corona too, which is the outer layer of its atmosphere. But of course, its size and glory are incomparable with those plastic costume crowns. And its shape is not so stable. Corona is a gas shell enveloping our parent star, so its size and form constantly fluctuate under the influence of the Sun's magnetic field. You can spot this crown with the naked eye from Earth during total solar eclipses. It looks like a beautiful, intense radiation around the solar disk, which itself is completely blocked by the Moon. The corona stretches 5 million miles above the Sun's surface, whereas our blue planet is only about 8,000 miles in diameter. So, one hypothetical ray of the corona equals a row of about 625,000 Earth-sized planets. And suddenly, all my problems begin to seem tiny. Now here's another fun fact. The Sun's corona kind of breaks the laws of known physics because it's hotter than it should be. Its temperature reaches 2 million degrees Fahrenheit, whereas the surface of the Sun is only about 9,000 degrees. Although the word "only" doesn't fit here, because it's still super warm in human terms. Usually temperature tends to fall as you move farther from a heat source, but it's not the case here. Space scientists are still scratching their heads trying to investigate this mystery. Thankfully, the recent photo shoot allows us to explore what's going on inside this massive hot stuff without risking losing our sight. Take these beautiful bright spots, for example. They depict solar flares happening under the corona layer. Solar flares are powerful explosions that happen when magnetic fields bump into each other. When it happens, they change shape and quickly reorganize. These fields arise from plasma, which is very turbulent itself, so these events are no surprise for the local weather. Now, who would have thought that the Sun has dark spots on its skin, just like people? These darker areas are known as coronal holes. Earthlings can experience their impact when they observe the beautiful aurora lights in the polar regions. Coronal holes look darker because plasma in these spots is cooler, less dense, and magnetically open. These conditions allow the solar winds to escape outward across the solar system rather than hang out at the Sun's surface. And when they bump into the Earth's magnetosphere, auroras emerge to fascinate our eyes. Thankfully, the local fields cool down the solar winds. Nobody wants their eyes to melt, right? Now, if we were looking for an analogy to the Sun's hairs, the best candidate would be solar prominences. These large, bright plasma loops arise from the Sun's surface and stretch for thousands of miles into space. Their lifespan varies from days to several months. It's one of the most common events in this region. Although the first detailed description of solar prominence dates to the 14th century, modern scientists are still researching how and why they're formed. Diving further inwards, we're facing the transition region. The thickness of this layer is about 62 miles, and the local weather is unthinkable. Temperatures can rise up to 900,000 degrees Fahrenheit. The transition layer sits between the corona and the last region of the Sun's atmosphere, called the chromosphere. Now, speaking of which, welcome to our next stop. The chromosphere region is famous for a scientific mystery called a spicule. Come on, say it with me. Spicule. Yeah, that's fun. These spectacular grassy-like jets of plasma fire upwards from the surface of the Sun and reach speeds of approximately 224 miles per second, as if they're jumping on a trampoline from the surface of the Sun. Each spicule lasts for just a few minutes in outer space before falling back into the solar atmosphere. Astronauts were having a challenging time trying to explain how magnetically charged particles could manage to escape the massive gravity of the Sun while being so close to it. The possible answer emerged in 2017. A group of scientists discovered that neutral particles provided the magnetically charged particles with extra buoyancy to escape the solar gravity for a while, which is better than my cousin's explanation, which is happy thoughts and pixie dust. Yeah. Now let's go ahead and travel 1,000 miles inward toward the chromosphere to finally reach the solar surface, the photosphere. It's around 248 miles thick. But unlike planet Earth, the Sun's surface is not solid or stable at all. The temperatures here are insanely hot for any matter to exist. On the other hand, scientists often call plasma the fourth state of matter. And why not? It's made of ionized atoms and free electrons, so it kind of deserves to matter. So what's the matter? Maybe someday we'll happen to meet the local civilization of plasmoid people. But I think it's best that we skip their welcoming warm hugs. You know, hot, hot, hot. Anyway, the photosphere is our final stop, because humankind doesn't have the technology to explore the Sun any deeper. So if you want to learn more, you'll have to invent your own spacecraft. But time's a-wasting. You'll only have about 7 to 8 billion years. After that, our Sun will fade away, according to scientists' estimates. Actually, those same scientists will be going first. Now, you have a serious competitor, though. NASA's Parker Solar Probe is the current champion for the deepest dive into the Sun. The spacecraft managed to travel 4.5 million miles from the Sun's surface toward its core on September 27, 2023. And then, the Parker probe repeated its own record once again in December of the same year. So, why didn't it melt, I hear you asking? The probe has been designed to withstand insanely intense conditions and temperature fluctuations. It's equipped with a custom heat shield and an autonomous system protecting the mission from the massive solar lights. NASA has further ambitious plans. In December 2024, Parker will make its closest approach to the Sun. It will travel faster than any man-made object has ever traveled, at the speed of 435,000 miles per hour. The probe will be just 3.8 million miles away from the Sun's glowing hot surface. It's like landing on a star. Astronomers have already compared this epic upcoming milestone with the moon landing. I'm thinking, however, it might be safer if we, landed at night. Yeah, you're right, that's an old joke.
From where we stand, the Sun seems so calm and peaceful. But like humans, and basically the whole living world, the Sun has its own phases when it's more or less active. It's just that the consequences are way bigger and more chaotic when the Sun becomes hyperactive. Let's zoom in to see what's happening up there. So one of the ways we measure the activity of our star is by counting sunspots on its surface. Sunspots are dark patches that form when the Sun's magnetic field gets all tangled up. It's simple. The more sunspots, the more active our Sun is. And it seems the Sun has been partying like crazy recently. The number of sunspots scientists have seen is the highest for nearly 21 years. In June, 163 sunspots appeared on the Sun's surface. The last time we had so many dark patches across the Sun was in September 2002, when there were 187 of them. Uh-oh. It seems this chaotic party is getting closer to its peak. And that's something we call solar maximum. How does all this even happen? The Sun's magnetic field is strong and organized at some point. But as we said, sometimes comes the time when it kinda ends up tangled. sort of like a ball of rubber bands that are wound together very tightly. This also means plasma is rising from the surface, forming loops, and causing a mess in the shape of solar flares and something we call coronal mass ejections, CME. That's when plasma in the sun's upper atmosphere, called the corona, goes crazy and bursts really strong. Then at some point, this ball snaps and completely flips and turns the South Pole into the North Pole and vice versa. All this happens every 11 years or so. So when the sun comes into this phase when it becomes very active, it shoots out hot blobs of plasma, gets big dark spots as large as planets, and releases powerful eruptions of energy and radiation. Something fascinating happens when the sun becomes more active. A thing called plasma waterfall or polar crown prominence, PCP. It's like a mini eruption that starts on the sun, and it seems like it tries to get away, but then the sun's magnetic field pulls it back before it can escape into space. And this plasma waterfall's really spectacular. It goes up to 62,000 miles above the surface. It's like you stack 8 Earths on top of each other. Then there's something called a polar vortex. It's like a gigantic halo of plasma that rotates around the sun's north pole really fast. This vortex happens when a large tentacle of plasma snaps apart and falls back toward the surface, similar to how a plasma waterfall forms. Scientists don't know why this plasma stays above the sun's surface for so long. And one of the cool examples of CMEs was a giant one in the shape of a butterfly in March this year. It got such an unusual shape because it exploded on the side of the sun we couldn't see, so it was impossible to fully measure how strong it was. Fortunately, that one didn't explode in our direction, but it might have hit Mercury a little bit. And it's possible it knocked off some dust and gas since Mercury has a weak magnetic field. All this sounds cool in theory, but it's not such good news for us. Because of all this, we might experience more intense solar storms that can, again, lead to geomagnetic storms on Earth. And these don't just sound alarming, they indeed are. They create chaos and disrupt the magnetic field of our planet. Geomagnetic storms can create beautiful northern lights, true. But we'd all rather enjoy such beauties as the aurora borealis in regular conditions, or just watch a good old sunset above the ocean. It's not that every solar storm will necessarily hit Earth, even if there are more of them. To reach our planet, they must be pointed in the right direction at the right moment. But if that happens, the storm can ionize the upper atmosphere and bye-bye our communications. It can cause temporary blackouts for systems such as GPS and radio. It isn't necessarily a big problem on its own, but it can be very dangerous if it happens at the wrong time, like during a tsunami or an earthquake. The storms can also damage electrical infrastructure, like rail lines and power grids. If you're on a plane at that time, you might be exposed to higher levels of radiation. It's still not clear how dangerous that will be for you, but it can be a serious problem for astronauts in space. When solar storms mess with the magnetic field, this can affect the migrations of some animals, such as sea turtles, whales, and birds. Since things in the animal kingdom mostly work in the natural order, who knows how these animals go through or even survive such changes? And when the sun is at a maximum of its activity, satellites in space are in trouble too. We have more satellites in space than ever before. And when the upper atmosphere becomes denser because of all these changes, this can push satellites in different directions. They might crash into one another, or some can even fall back to Earth, which again is only cool in movies with superheroes who can relatively easily deal with this stuff. Hopefully, we'll avoid a massive solar storm like the Carrington event. The story was similar. In August 1859, astronomers across the globe watched how the number of sunspots was getting bigger and bigger. A man named Richard Carrington was among them. At the beginning of September, he was sketching the sunspots when, out of a sudden, he was blinded by a flash of light. It lasted around 5 minutes, but it was spectacular. He later described it as a white light flare. It was a very strong coronal mass ejection, CME, and in only 17.6 hours, this storm crossed the long way between the sun and our home planet, 90 million miles, and unleashed its force on us, even though this usually takes days. And when this storm started, telegraph machines across the world sparked. Operators got electric shocks, and paper even caught fire. People were really scared and confused because they had never seen such bright skies before. Some even thought it was the end of the world. The next day, Telegraph workers still couldn't work properly because Earth's atmosphere was still charged. They even managed to send messages using the auroral current instead of regular electricity. But it brought something incredible, 2 stunning auroras in the sky. People in Hawaii and Cuba could see beautiful northern lights, while those as far north as Chile could see the southern lights. It's all slowly but steadily escalating. Take solar flares, for example. These are powerful bursts of energy from the sun. In 2022, there were 5 times more of these flares compared to the previous year. Plus the strongest ones, X-class flares, have been getting stronger and more common than before too. And this might be way more extreme than anyone thought. Plus, it's likely to start a little bit earlier than we predicted. Scientists first thought the peak would happen in 2025, but it seems it could even occur by the end of 2023. We can't completely protect ourselves if a solar storm hits us directly, but we can still do some things like ground planes, adjust the paths of satellites in space, and try to make sure vulnerable infrastructure stays safe. To do all this, we need better solar weather forecasts to help us get ready for the worst. All this might sound very bad at first, but don't worry, solar flares won't destroy our planet. They do send charged solar material toward us at pretty high speeds, but it's not like we're completely doomed if these things hit us. Our planet won't leave us unprotected. We still have the atmosphere and magnetic field that keep us relatively safe. Our thick atmosphere is like a shield that blocks radiation that might harm us. So these solar flares can mostly affect technology, but they won't destroy Earth. I guess we have our own superheroes after all.
Tidal locking is when a moon or a planet always shows the same face to another celestial body. I know I do. The moon, for instance, always shows one side to Earth. It doesn't matter if you use binoculars or a telescope, you'll see the same craters and plains every time. This happens with many big moons in space. Take Jupiter's moon, Io, or Saturn's moon, Enceladus. Even Mercury, which rotates 3 times around its axis for every 2 leaps around the Sun, is almost tidally locked to our star. Now here on our planet, the moon's pull creates tides on Earth, making the water rise about a foot. This pull also stretches the moon, making it slightly football-shaped. Many years ago, the moon spun way faster than it does today. This made its protruding parts shift constantly, like the Earth's tides. But the moon's bulges didn't align with Earth's pull. Soon enough, the Earth's gravity pulled them in closer, slowing the moon's spin until it stopped. But if we look at the grand scheme of things, we'll see that our planet isn't tidally locked to the Sun. Earth rotates on its axis, completing one rotation roughly every 24 hours, while orbiting its star. This rotation creates day and night. Lots of things prevent our planet from constantly showing the same face to the Sun. First, Earth's rotation rate isn't perfectly synchronized with its orbit around the star. The presence of the Moon also plays a crucial role. Our satellite's gravitational pull creates tides on Earth, which slightly slows down Earth's rotation over time and balances things out. There's also quite an impressive distance between the Sun and the Earth, 93 million miles. So even if the Sun's gravitational force is intense, it's far enough away to prevent tidal locking. Now, what if space travel gets advanced enough that we end up visiting such a tidally locked planet, one that is constantly trapped between 2 extremes, eternal darkness and constant sunshine? We can gather some data by figuring out what would happen if the Earth suddenly stopped spinning on its axis. Bad news is, the consequences would be devastating. Right now, we're all moving along with Earth's rotation, even if we don't feel it. If the planet stopped, everything on its surface would be launched eastward. People, buildings, and natural features hurtling sideways at high speeds. Afterward, the remaining high-speed winds, still rotating nearly as fast as the planet, would damage its surface, acting as a cosmic nail file. Even if the slowdown happened gradually, the effects would still be dramatic. The first noticeable change would be the Sun's motion across the sky. Without Earth's rotation, a day would last a half a year. This disruption would throw off our biological rhythms, affecting sleep dynamics and daily activities for many species. Earth's rotation also influences atmospheric patterns, which affect the weather and climate. Air currents would change too, leading to extreme events like desertification or the melting of polar ice caps. Hurricanes, reliant on Earth's rotation to form, would cease to exist. A motionless Earth would likely translate to the loss of our magnetic field, which shields us from harmful cosmic rays and solar storms. Boy, we in trouble now, huh? In the same thought experiment, let's say oceans won't freeze where it's cold or evaporate where it's hot. Because of its spin, there's a centrifugal force that has made our planet a bit wider around its middle. If we measure the Earth around the equator, it's about 13 miles wider than if we measure it from pole to pole. This widening of the solid Earth happened very slowly over billions of years. But the liquid water in the oceans would move more easily. Because of the spin, the water around the equator is about 5 miles higher than it would be on a still planet. If the Earth stopped spinning, the oceans would start moving towards the poles. At first, only some areas around the equator would become land. But eventually, a big continent would form in the middle, like a belt. You could walk around the Earth at the equator without getting wet, even though it would be really cold on one side and really hot on the other. The water that might move away from the equator would end up at the poles. There would be 2 separate oceans around each of these points, with no connection to the equatorial continent. In the north, Canada, Greenland, Asia, and Europe would all be underwater, following a line similar to the border between the US and Canada. But countries like Spain, for instance, would mostly stay above water. Despite these extremes, some say life could still exist in the twilight zone between light and dark. If we could draw it, it would be this softly illuminated region, looking like it's always on the brink of a sunset. This in-between domain could potentially offer the ideal conditions for life, with temperatures balanced between extremes. The planet would end up resembling an eye. Its sunward-facing hemisphere would look like a parched pupil, encircled by a blue-green iris, the place with lots of water and vegetation. Now, it's not all that grim. Since there's liquid water on our planet's surface, sunlight could turn it into clouds that could help us control the temperature should it stop spinning. Also, the way heat moves around in the air could make the climate nicer overall. Winds could carry warmth from the sunny side to the dark side, similar to how ocean currents warm up Europe and cool down Africa. Plus, the way gases move in the air might stop a planet from getting stuck facing one way all the time. Venus, for instance, should be locked in place facing the sun, but its atmosphere helps keep it turning. Our planet might end up pulling a similar trick. Rainfall on a tidally locked planet could further regulate temperatures, especially if there's enough land. On Earth, rain interacts with rocks, trapping carbon and cooling the atmosphere. This process could also help manage carbon dioxide levels. If we were to prepare for a tidally locked world, the Sahara Desert would be a good place to start the boot camp. Located in North Africa, it is the biggest hot desert globally. It covers a vast area from the Atlantic Ocean to the Red Sea and from the Mediterranean Sea to the Sahel region. During the day, the temperatures get really hot, up to 122 degrees Fahrenheit, and at night, it can get as cold as 41 degrees. That is a wide swing. You might stumble upon a sandstorm here and there, but rain is very rare. When it does happen, though, it's intense and can cause flash floods, making the area dangerous. Despite the tough conditions, some animals manage to survive here. One such creature is the Kenneck fox, which is the smallest fox to exist on our planet. It has big ears that help it handle the heat, and its environment stretches from Morocco to Egypt, and even down south to northern Niger and east to Kuwait. It eats whatever birds, insects, and rodents it can find in the sand. As for the coldest place on Earth, data suggests it's located in the eastern Antarctic Plateau. Research indicates that the air temperature there can drop to minus 137 degrees Fahrenheit. Now, if we need to find animals that have adapted well to living in refrigerator with built-in ice maker-like conditions, we just need to look at the emperor penguins. They gather in tight groups, sometimes with huge numbers of these birds, to keep warm. They can't stay in these huddles for too long, though, because they get too hot. Scientists found out in 2015 that it can get as hot as 100 degrees Fahrenheit in the middle of the penguin mosh pit. These birds are the only animals that produce offspring during the Antarctic winter. They travel quite far, somewhere around 50 to 100 miles, to lay just one egg. While the dad keeps the egg warm for about 2 months, Mom goes back to the edge of the ice to find food. It's a routine that usually works well, as long as the weather is consistent.
The Sun is getting ready to flip as its magnetic poles are reversing. Similar to Earth, the Sun has a magnetic north and a magnetic south. But unlike Earth, the reversing process of the Sun's poles is more frequent and easier to predict. The next flipping is expected to take place this year between April and August. As apocalyptic as it might sound, you don't have to worry. If you're around 30, you've already experienced this phenomenon more than once, as the Sun flips every 11 years. You probably didn't notice any changes back then because this process doesn't impact Earth's life so much. But this time, things might be a little different. On Earth, ocean currents are movements that play a crucial role in influencing both climate and weather by distributing heat from the equator to the poles. On the Sun, these currents are more like an ocean of plasma, but they not only transport heat but also carry electromagnetic energy. That happens because the Sun is a huge ball of hot and ionized gases that keep flowing inside its core. By fusing together hydrogen atoms and forming helium, our star releases a massive amount of energy, leading to these very heavy flowing electric currents. And whenever you have currents, you have magnetic fields. It's easier to understand if you think of that classic experiment with a wire and a nail that you probably conducted in elementary school. When electricity flows through a wire, it creates a magnetic field around the wire. So when you connect a wire to a battery and wrap it around a nail, the nail becomes a magnet. This is similar to how electric currents create magnetic fields on the Sun. This whole process, with the help of which the Sun generates its magnetic field, is called a dynamo. We can't observe it directly, but we can see its effects on the Sun's surface. When plasma and magnetism flows become unstable and intense, they manifest as sunspots. You know, those dark areas on the Sun's surface? Much about how the dynamo works remains a mystery. But scientists have learned something important after observing these sunspots for centuries. The dynamo process follows a pattern. About every decade, it reorganizes itself. The Sun's polar magnetic fields get weakened, eventually reaching zero, and then they return, but with the opposite polarity. Back in the 50s, researchers figured out that when sunspots start to ramp up and become more intense, it means the poles are gearing up for a reversal. And over the past few years, solar activity has been off the charts. We're talking about more solar flares, more electromagnetic radiation bursts, and more plasma blobs being ejected into space. It's like we're sitting in the front row at the solar system's most epic fireworks display. In fact, the Sun hasn't been this lively in probably 2 decades. Right now, experts think the polar fields are almost in sync and steadily weakening, inching closer and closer to zero. But we haven't reached the point of reversal yet. Although it might sound like the Sun flips its magnetic poles like clockwork every 11 years, the truth is that it's not as neat as it seems. This path can be bumpy, and some aspects of the phenomenon are still very hard to predict. Take the last solar cycle, for example. The Northern Hemisphere started its magnetic flip back in early June 2012. But then it kinda hit a snag and lingered around the neutral point until late 2014. Meanwhile, in the Southern Hemisphere, things were smoother, with the polarity switching over in mid-2013. This time around, the Sun is actually playing nice. Things seem to be running way smoother this cycle, with the poles transitioning more evenly. But here's the thing, reversal processes are never the same. That's what makes this phenomenon so interesting to observe. But at the same time, it's hard to predict how it'll affect us down here. Here on Earth, we don't have to worry too much about those intense sun explosions happening 93 million miles away. But if, and I emphasize if, a solar storm were to reach our planet, the main threat it would bring would probably be the disruption of communication satellites in space. However, things might be different in this cycle reversal happening in 2024 because the number of satellites has skyrocketed in recent years. For example, Elon Musk's Starlink system alone involves more than 4,000 of them. All these satellites, along with communication and GPS satellites, could be impacted or even destroyed by a powerful solar storm. Although the chances of a powerful solar storm hitting Earth are low, it's not impossible. Back in 1859, during the Carrington event, a storm occurred near the peak of the solar cycle, causing currents to surge through telegraph lines, sparking fires and disrupting messages worldwide. Earth fell silent as telegraph communications failed. Just imagine what a solar storm could do to our vast number of satellites today. It could affect everything we rely on daily, from space-based communication and navigation to weather forecasting services. The ground-level power distribution could also be affected. You can forget about watching YouTube or Brightside, because if such an event occurred today, it would cause an internet apocalypse, sending countless people and businesses offline. There's a prediction that says that if a Carrington-class event happened today, it would result in damages ranging from $0.6 to $2.6 trillion. And I'm talking about the United States alone. Fortunately for us, solar storms as intense as the Carrington event happen only once every 500 years or so. Bad news for communication satellites, but great news for aurora watchers. During the Carrington event, dazzling auroras borealis lit up the sky as polar light shows stretched far beyond their usual ranges. The northern lights were spotted as far south as Cuba and Honolulu, Hawaii, while the southern lights were seen as far north as Santiago, Chile. For many people around the world, this was their first glimpse of the aurora, leaving them obsessed with the unusually bright skies. Some of them thought it was the end of the world, while others began their day early, thinking the sun had risen after hearing birds chirping and seeing the bright skies. Today, we know there's nothing strange about it, considering that the appearance of auroras at lower altitudes is one of the expected effects of the sun's magnetic pole reversal. Typically, these dazzling phenomena are found between 60 and 75 degrees latitude, but during the last magnetic pole reversal in 2013, intense auroras were observed below 50 degrees. Eyewitnesses describe these auroras as blood or deep crimson red, shining so brightly that you could read a newspaper in their light. It's important to study this phenomenon and not to fear it. The inversion of the magnetic poles on the sun is actually a great opportunity for scientists to better understand how our star works. Since many pieces are still missing in the whole dynamo situation, we're still not very good at predicting why some solar cycles are more intense than others, or when exactly a coronal mass ejection will erupt. But being able to predict that is becoming more and more necessary as we venture ourselves into space. The more people are out there beyond Earth, the more exposed they are to these strong solar storms. That's why the scientific community wants to know more precisely when a solar storm can cause damage to spacecraft and space stations. Plus, it would help meteorologists make progress in predicting weather, not only on Earth, but also in space. The whole point is to make space travel safer as the interest in crewed missions to the Moon and Mars grows every year. Another reason why it's important to learn more about the Sun's pole inversion is to better understand how the mysterious interior of the Sun works. That could actually help us figure out the aspects of other stars in the universe and maybe get closer to answering the ultimate question: why are we here?
What happens when a star runs out of its fuel? First of all, paradoxically, it grows to 1,000,000 times its original size. You see, when the core of a star runs out of hydrogen, it starts contracting under the weight of its own gravity. But some hydrogen fusion continues in the upper layers. While the core contracts, it heats up. This causes the upper layers of the star to heat up too and expand. The radius of the star increases. As the star grows, it engulfs any matter, even its own planets, in its wake. Astronomers have watched stars right before or straight after swallowing entire planets, but until recently, they have never seen the process itself. Scientists from different universities have reported that for the first time in history, they've observed a star swallowing a planet. And this tragic event happened not somewhere in a faraway galaxy, but in our own Milky Way, some 12,000 light-years away from us. astronomers spotted an outburst from a star, which is around 0.8 to 1.5 times the mass of our Sun, near the eagle-like constellation Aquila. It became over 100 times brighter than usual in a mere 10 days, and after that, it quickly faded away. Even more interesting, this white-hot flash was followed by a longer-lasting signal that was also colder than the first flash. And this combination, my friend, could only mean one thing. The star engulfed a nearby planet. What planet was it? Astronomers believe it could be a boiling hot world from 1 to 10 times the mass of Jupiter. Such planets are also called hot Jupiters. They're giant exoplanets similar to the Jupiter we have in our solar system that need less than 10 days to orbit their stars. The planet we're talking about had been gradually spiraling toward the star until it was pulled into its atmosphere and, eventually, into the core of the perishing star. This galactic feast happened between 10,000 and 15,000 years ago when the star was about 10 billion years old. And given its respectable age, the swallow itself happened lightning fast, in one fell swoop. This is very different from other hot Jupiters, which were quite delicately nibbled by their stars. Astronomers aren't sure if there are any other planets orbiting this star, perhaps at a safer distance, but even if there are, thousands of years will probably pass before they become the star's main course or dessert. In any case, now that astronomers know what they should search for, they're going to be on the lookout for more cosmic gulps. Because one day, our planet, as well as part of our solar system, will suffer the same fate. Everything around us will be gone in a flash. But you may relax and breathe out. It won't happen for another 5 billion years. That's when the sun is supposed to burn out and expand so much that it will swallow the inner planets of the solar system, Mercury, Venus, Earth, and Mars. If people manage to colonize some other world by that time, which should be at least 10,000 light years away from Earth, they would be able to observe this catastrophe. The sun would suddenly become much, much brighter, and it would eject some material into space. It would swallow several planets, including Earth, before nonchalantly setting back to what it was. But stars are not the only things in the universe that swallow other space objects. There's another kind of cosmic monsters that munch on everything, even light. Have you guessed? Right. I'm talking about ruthless black holes. But what is more interesting, they not only devour stuff but also seem to spit it out. Not so long ago, scientists found out that the supermassive black hole at the center of our home Milky Way galaxy seems to be leaking. Why is it a game changer? Because it might mean that this black hole, called Sagittarius A*, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active, and this leakage may be the whole hiccuping while swallowing clouds of gas. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often happens around active black holes, surrounded by the material, pulled toward them by their immense gravitational pull. Some of this material gets into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches mini jets of matter. Fermi bubbles might be the result of the belches that happened around 2 to 4 million years ago. But recently, scientists have discovered another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now I'll tell you something even creepier. There seem to be black holes that might be eating each other. Well, kind of. They're actually trying to share their meal at the moment, but who knows what will happen in the near future. But let me go into detail. Astronomers have spotted 2 supermassive black holes, feasting on the cosmic material of 2 merging galaxies in distant space. These giants have been located with the help of the Atacama Large Millimeter Submillimeter Array of Telescopes, also known as ALMA. These telescopes are in northern Chile's Atacama Desert. Scientists originally used them to watch 2 merging galaxies located about 500 million light-years away from Earth. Astronomers have also noticed that two gigantic black holes were growing alongside each other not far from the center of the coalescing galaxy, UGC 4211. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, about 125 million times the mass of our star. Even though they aren't visible directly, the black holes are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Times will pass, and these black holes will start circling each other. And eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are kinda unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. Interestingly, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around black holes. Imagine how surprised astronomers were when instead of one black hole, they saw two of them, munching on the dust and gas stirred up by the massive space merger. The most important thing about this discovery is that it may mean that such black hole binaries are likely to be much more common than we previously thought. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves that occur when black holes collide. Such waves are also known as ripples in spacetime. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes that are about to collide exist in the universe.
Let's face it, as stars go, our sun is actually, well, pretty boring. Come on, there's nothing unusual about it. There are millions of similar yellow dwarfs in the universe. And yet, we love it. After all, it's the only star we have, and it gives us life. However, it wasn't always like that. Once upon a time, the sun had a twin, possibly an evil one. What happened to it? Well, let's find out. Now this here is a giant molecular cloud. They're also sometimes called dark nebula. Here, there are many interstellar clumps full of gas, dust, and piles of stars. These clouds have no clear boundaries and often take weird, crazy forms. You can even see some of them with the naked eye. Look at the clear sky at night. They look like dark spots all across the bright Milky Way. And this is exactly where our sun was born about 4.5 billion years ago. The sun originated from one of these molecular clouds. Billions of years ago, waves of energy were passing by here. They collected all this material and compressed these clumps into dense nuclei. That's when a protostar was born. This young protostar was a ball of lukewarm hydrogen and helium. And then, millions of years later, the temperature and pressure inside the balls increased. As a result, a star was born, the sun. But not everything in this molecular cloud has turned into the sun. The remaining materials began to revolve around the new star. And as you might have guessed, they gradually turned into planets, including our Earth. This is how our solar system was created. But it's quite possible that this is not the whole story, and that at the same time, along with our star, another one was born. The lost twin of the sun, made from the same materials under the same conditions. But why do we think that it exists? Well, recently, scientists have launched some statistical models to find out more about the birth of stars. And these models have shown that many stars appear not individually, but in clusters, or at least with one sibling. After more research, scientists confirmed that, yep, most stars formed inside molecular clouds are born with a companion. Sometimes these companions stay together. For example, a small star will revolve around a large one. They can even form double, triple, and other star systems. And sometimes their paths may diverge forever. This probably happened to our sun as well. It could have had a sibling too. Perhaps not even one, but a whole cluster of little brothers and sisters. And one bigger twin with a similar mass and other characteristics. But if that's the case, then where are you, our lost twin? Well, we have one hypothesis, and according to it, this twin may not be as good as it seems. In the 1980s, scientists began to notice a certain pattern in the Earth's history. Approximately every 27 million years, give or take, large-scale extinctions occurred on our planet. Pretty strange, right? Every 27 million years in the history of Earth, some kind of catastrophe occurred that changed its biosphere forever, as if something, as scheduled, cyclically, caused them. Then an astronomer, Richard Muller, suggested that there may be something that caused the events, a certain celestial body. According to him, it could be a dwarf star that we can't see because of how dim it is. It could be located about 1.5 light years away from us. This star rotates around the Sun in a huge orbit, and it approximately takes a whopping 27 million years for it to finish its orbit. And when it gets closest to the Sun, it starts to cause complete chaos. While approaching us, this troublemaker changes the trajectories of comets in the Oort cloud or the Kuiper belt. As a result, all these comets start to rush straight toward us. Then they crash into the Earth and cause mass extinctions, just like it was with dinosaurs. This hypothetical star was named Nemesis. It's the name of the ancient Greek deity of retribution. What is it taking revenge on us for? No idea. Perhaps it didn't like the fact that once upon a time, the Sun took away almost all the dust and gas from a molecular cloud. The Sun became a fairly large star, but the twin remained dark and small. Moreover, in the end, it was forced to fly away in the middle of nowhere. Anyone would be annoyed by something like this. Scientists have put forward various hypotheses about what the mysterious Nemesis is. Perhaps it's a brown or red dwarf, the remnants of a star that has completely depleted its fuel. Or maybe it's not a star at all, but a rogue planet more gigantic than Jupiter. Well, whatever it is, its existence isn't particularly pleasant for us. However, all our attempts to find the culprit unfortunately failed. At the moment, we still haven't found any signs of Nemesis. Recent studies have called into question the theory of regular mass extinctions. If you look more into fossil records, you'll notice that these catastrophes occurred rather randomly, rather than on a clear schedule. Now scientists doubt if Nemesis may actually exist. They also say that any star moving in a similar orbit would be very unstable, and it's very unlikely that it could have survived for that long. But despite the lack of clear evidence, Nemesis had become quite famous online. Many articles and news still mention it in different contexts. They like to write off any dramatic events taking place in the world, like asteroid falls, tsunamis, and so on this mysterious star. So now, all this may seem like a typical urban legend. But let's not forget about something important. Even if Nemesis itself doesn't exist, it doesn't mean that the Sun didn't have a twin. First of all, everything we talked about at the beginning is still relevant. Most stars aren't born alone. The probability that our Sun also had a sibling is still very high. Secondly, there may be evidence of the existence of this lost twin, and is probably somewhere in the Oort cloud. This is a huge cloud in the outer limits of our solar system. It consists of a bunch of comets and other cool rocks. Now, scientists believe that this cloud stores various remnants and fragments of everything that remained after the birth of our solar system. It's like a huge museum of our past. So, in this Oort cloud, scientists have noticed something interesting. Basically, this region seems to be too heavy. What the Oort cloud actually looks like doesn't correspond to our current models of the formation of the solar system. It's too heavy because there are some remnants of something in it. So, there used to be something in the solar system that we don't know about yet. But when scientists included a possible second sun in their calculations, it fit just right. Like a missing piece of a puzzle, the lost twin perfectly matches the gap in the weight of the Oort cloud. So yeah, the Sun almost certainly had a twin. But what happened to it? And where is it now? Unfortunately, this star is most likely already very far away. Probably after their birth, the Sun and daughter, Sun 2.0, spent only a couple of million years together, and then they had to separate completely. Now, the second twin may be hundreds of light years away from us. It can be anywhere in the Milky Way. And yeah, theoretically, we could find it, but that would be quite difficult. To do this, we need to find all the stars similar to our Sun, about the same age, all over the Milky Way galaxy. And even if we make a list of these stars, what's next? We have no way of knowing which one was really the twin of the Sun. So, the lost twin will most likely remain lost, and our Sun will remain forever lonely. What a sad story. But cheer up, for us it's probably the best. If we had two suns, perhaps the solar system would never have become what it is now. Our planet might not exist at all, and that means that there might be no life. So we probably should be grateful for the sun's sacrifice. On the other hand, our sunsets would look like the ones they have on Tatooine. Cool.
Is it possible to put out the sun? For example, what would happen if we poured all of the Earth's oceans on it? Or even more water? Well, let's find out. The universe is a place full of mysteries. Since ancient times, scientists have been arguing about how space works. But none of us has ever doubted the existence of one thing: the sun. The center of our solar system. It's big, bright, and immortal? Nah, not really. Actually, the sun is just an ordinary star. It consists of 75% hydrogen, a little helium, and a pinch of other heavy elements. Gravity holds it all together. But in around 5 billion years, the life cycle of the sun will come to an end. The hydrogen inside it will run out. Our star will begin to grow gradually, and you can't even imagine just how big it will become. And then it will start eating all the nearby planets. That's when we'll regret being so close to it. After eating us all, the star will remain a red giant for another billion years or so. And then, sooner or later, it will begin to shrink and fade, turning into a white dwarf. In the end, nothing will remain of it but a bright and colorful planetary nebula. But don't get scared. Right now, the sun is in the middle of its life cycle. It was born about 4.5 billion years ago, and about the same amount of time remains. Fortunately, we were born during the star's best and most stable period. In other words, there's no reason to worry. So let's find one. How about speeding up the sun's life cycle with the help of water? We'll try to collect all the water on Earth and pour it onto the sun. First, we'll need a bucket. No, not this one. We'll need a really, really big bucket. The one that can contain around 326 million cubic miles of water. It will be equal in size to the distance from Washington to Chicago. Or if we can only find ordinary buckets, there should be around 70 quintillion of them. This is a number with 18 zeros. Okay, imagine that we magically got that many buckets. It's time to put out the sun. We splash the star with all this water and nothing? Seriously? Oh, just look at this. The sun has probably felt sorry for us and produced one little solar flare. It turns out that all water on Earth is actually just a pathetic drop for the sun. People often underestimate how much bigger the sun really is than our planet. In reality, it can fit more than 1,003,000 Earths. So yes, the sun won't go out or even get colder. It won't even notice that we've done something. But let's not give up. We really want the sun to go out for some reason. What happens if we pour just enough water on it? And how much is this enough? Remember our quintillions of buckets? Well, we actually need about 370 octillions of them. This number has 27 zeros. It's hard to even imagine, so let's just say that it's a lot of water. Now, let's splash it all over the sun again. Wow, just look at the steam! But the sun hasn't gone out again. On the contrary, it said thank you and suddenly became much bigger and brighter. What's happening? You see, the sun isn't actually a campfire. Inside bonfires, candle flames, there's a chemical combustion. When we pour water on the fire, the water absorbs the heat of the flame and cools it to such an extent that it can no longer maintain the burning reaction. It also blocks the fire's access to oxygen. Water basically stops the chemical process. But the burning of the sun isn't the same reaction. Even though we say it burns, it's not entirely true. What happens there is called nuclear fusion. It's one of the most violent and craziest reactions in the universe. There are many layers of hydrogen going deep into the sun. If you take 4 hydrogen atoms and ram them together, you're left with an atom of helium. When we talk about the sun, the process is a little more complicated. When the star tries to carry out that fusion, positive protons repel each other. It takes a lot of force and energy to somehow squeeze them together. Fortunately, there's a magical force in space. It's gravity. The sun takes up 99.8% of all the mass of the solar system. Pretty heavy, right? And all this mass is what holds the sun together with the help of an incredible gravitational force. So, gravity takes quadrillions of these little hydrogen atoms and pushes them together every second of every day. And when they collide, they release some energy. So, unlike fire, the sun doesn't need oxygen to live. It needs hydrogen. And we all know that water is H2O. It consists of hydrogen and oxygen. So this is literally fuel for the sun. It's like trying to put out a fire with gasoline. More importantly, the extra mass added by water will make the sun heavier. Now, gravity says, "Thank you for your help." And then it starts to collide protons with each other even faster. And thanks to this, the synthesis speeds up. Great, we've made the sun incredibly strong, and now it has eaten us, along with other nearby planets. And if we keep adding water, the sun will sooner or later collapse in on itself. It will blow off its outer layers and become a black hole. Awesome! Now it will pull inside absolutely everything around. Good job, guys. Let's press rewind because clearly our water experiment was a mistake. One small solar flare sounds much better. Alright, we're back to our usual calm sun. But it seems like there's something that we've forgotten. Well, apparently, water was critically important for life on Earth. Who would have thought? Now there's a huge amount of unmoving fish and other marine creatures lying around where the oceans used to be. Poor things. As for deep-sea creatures, they simply didn't withstand such a sharp change in pressure. Algae and corals have also dried up. Wait a minute, weren't they responsible for producing 50 to 80% of the world's oxygen? Oops, it's time to put on some oxygen masks. And how are things on dry land? I mean, now everything is just land. But you get the point. Wow, this whole place is lit, and I mean it literally. If there are no oceans, then there are no clouds or rain. Now there are forest fires everywhere. Poor animals have to escape and leave their homes. Oh my. And it's not like they'll be able to find a new home, because all plants, of course, will dry up quickly. There will be literally no place for living left on the planet. So now Earth looks like a giant desert. Great! But people have been living in deserts for thousands of years, right? Maybe they'll know what to do. They won't. After all, people in the desert also need to drink. So now there's total chaos everywhere, and survivors fight for the last drops of water. If there are any survivors at all. In fact, no matter how much they fight for resources, their fate is sealed. The ocean absorbs a huge amount of CO2 and the heat coming from the sun. They also distribute this heat throughout the planet, making it pleasant to live on. But once they're gone, the temperatures will quickly jump to 250 degrees Fahrenheit and above. But even if we forget about the high temperatures, now we have no clouds, and they helped us too, by not letting through solar radiation. So we're also under the direct impact of the sun's rays. Our last hope is icebergs. Now that everything is terribly hot, they've melted. And maybe they'll be the last hope for humanity. But that cool solar flare was definitely worth it. Silly humans.
So, what's going on with all the news about the sun? Some say that the sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the Sun is likely to get. The Sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the Sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the Sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the Sun gives off. Thankfully, the amount of visible light the Sun gives off doesn't change very much. That would be a serious problem. If the Sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the Sun is. The more sunspots that are visible, the more active the Sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the Sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The Sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the Sun. High-speed electromagnetic plasma gas from the Sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the Sun, but they aren't dark. They're just not as bright as the surface of the Sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the Sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the Sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the Sun associated with sunspots. As the superhot plasma gas on the Sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the Sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the Sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the Sun's surface. The corona of the Sun is much hotter than the surface of the Sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the Sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the Sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the Sun. Cool, huh? Turns out the Sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California that keep a constant watch over the 10 million sound waves moving on and around the Sun. Now that the Sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the Sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders.
The Sun isn't technically the center of our solar system. It's in a space called the barycenter. It depends on which planet you're standing in. The barycenter is usually closest to the object with the greater mass. So, since we're on Earth, the true center of the solar system is the Sun, but not the center of it. With respect to Jupiter, the barycenter is actually outside the Sun's surface. Jupiter is 318 times bigger than Earth, so the balance is different. The planets don't really revolve around the Sun, but around their common center of mass. Imagine balancing a pencil on the tip of your finger. You'd have to place it right in the center so that it doesn't tip on each side. Because the pencil has its mass equally distributed, it's easy to assume that everything balances its way like that, especially in outer space. But try balancing a hammer on the tip of your toe. Chances are you'll walk out of here with a broken toe. Its true barycenter is close to the hammerhead rather than the actual center where you'd grip it. Earth and the Sun's barycenter is like that hammer. The center of mass is more or less in the center of the object. Realistically, if the sun were to rotate around Earth, then our little blue planet would have to be just as big as the sun, or bigger. We can't disregard the other planets in our solar system, which means they all will have to rotate around us as well. But in the ancient days, bright minds always thought everything revolved around the Earth. They called this the geocentric model, and this made sense to them because it looked like everything above us was spinning around us. The sun and the moon played vital roles in human history, and we didn't feel insignificant in the universe until way later on. In ancient Greece and the Middle Ages, the big brains used the geocentric model to study space. It wasn't until the 16th century that that model changed. Back in those times, they couldn't even imagine that everything revolved around the sun, and they didn't have the knowledge to back any of this up. The Earth can't be the center of the solar system because it's not large enough for the job. For the conditions to suit the enormous size, life would have evolved differently. We'd probably be less dependent on oxygen. Some animals, like whales and dolphins, can stay for hours without taking a single breath. They can even sleep underwater. So the humans of the sun-sized Earth would have specialized lungs and wouldn't need to constantly be taking in air. It means that the plant life would be limited, with just a few shrubs here and there. There are trillions of trees around the world, but the main contributor to producing oxygen is the algae in the ocean. With such vast real estate of oceans and seas, the algae sitting on top are pumping out the air we breathe. Oxygen wouldn't be so abundant on this planet, but our breathing mechanisms might rely on carbon dioxide, another common gas found on other planets. If the planet is hot, then water will be scarce. We would only find it on certain parts of the planet, like mountaintops. The ground would be too scorched for anything to survive in properly. We can forget about seasons as well. The sun is currently just large enough to give us what we need. But since the Earth would be so large, and the sun would be another celestial body emanating heat, we'd always feel like we're inside a microwave. The days and nights will be different, and not much precipitation will happen. With so much heat produced in the core, earthquakes and volcanoes would likely erupt all the time. The surface would practically be a scorching plain of red magma floating around. This would be the true red planet. But if we had the same landscape like on Earth, living somewhere near the mountains could save you. The mountains would still be embedded in the core, but it would be better than staying on the ground. Some of the mountain peaks could even be 100 times taller than Mount Everest. The canyons could be so deep that the Mariana Trench would feel just like a little rupture. Animals would also behave and look different. Cold-blooded animals would have to soak up as little sun as possible so they don't burn. Animals would have to rely on migration to find water in distant lands. Birds can fly for hundreds of miles for migration season, so we'd probably see certain sleek-looking birds speeding through the air. But because gravity would be so strong on the colossal-sized Earth, the flying animals would need thinner bones and a thinner core just to take flight. The real survivors would be the microorganisms. They can live in extreme temperatures and pressures, and can live without oxygen for a good while. The nights would be dark since there wouldn't be any moon to reflect the sunlight. The moon would most probably be on the opposite side of where the sun is shining, so it would forever be a floating ball in the sky. The Earth's rotational speed is the fastest at the equator, so if all the planets and the sun rotated around us, then our rotation wouldn't be so significant. New weather patterns wouldn't be good for crops. Humans would have evolved differently from what we are like now. We'd probably be shorter and stockier since gravity is so strong. And because of the soaring temperatures, we'd probably live in caves all around the world. The strongest ones would have migrated to the mountains. We'd probably have the same evolutionary path as we do now, but other physical features might be different. Our pigment would likely look different to combat the heat. The desert fox has large ears for hearing out predators and for cooling itself down in the scorching desert heat. It's possible that we would also have bigger ears than what we have now for the latter reason. We'd be a lot stronger than we are, and our bones would be thick and tough to break. Gravity is one of the key components to developing our bone density and muscle mass. This means we would unlikely need tools for hunting. This would have delayed the Bronze Age and modern civilization as we know it. With little vegetation, standing upright wouldn't be so necessary to find predators around us. We wouldn't be the fastest runners either, but we'd be strong enough to fight off a pack of strange-looking wolves. And if the Earth was supersized, then it's possible that multiple species of humans would be roaming the land in isolated areas. Some human species would grow and evolve into the intelligent thinkers of today, but some would remain the same. And some creatures from the past would still be around, unchanged. Sharks would have been around since the dinosaurs era. They wouldn't have to change their form or adapt because of their dominance. Other animals would remain the same because of their isolation. The Galapagos Island hosts some unique animals because they've been alone for so long. Without proper predators constantly lurking around them, they don't fear humans. The new mega-sized Earth would have areas as large as Asia filled with isolated animals that could remain the exact same as when they first appeared. The human species of those regions would also remain the same, since they wouldn't have moved or experimented with anything. Their diet would remain the same, and they would get used to the climate they're in. Technology would also have flourished differently in various parts of the planet. With some areas in complete isolation, they wouldn't have access to new gadgets and inventions. It would be like living on a planet with different eras in the present day. Other areas would be so advanced, they might even be flying themselves outside the planet in search of truth and answers. Our gravity is good enough for us to live properly and develop life, but if we pumped up our size to that of Jupiter, then gravity would crush us. And being the size of the Sun, Earth wouldn't even be a planet, but a brown dwarf, and would constantly be burning until it became a new sun. As of now, Earth is so small in our universe that we're practically like a grain of sand in the desert. On a cosmic level, we're an insignificant contribution to this universe.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernardinelli Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
Arcturus, a huge red star. It's just bursting from inside out. The red sea of plasma on its surface rages and pulsates. The star burns anything that comes close to it. And now, flop! Arcturus is gone. But at the same moment, it reappears at the center of our solar system, replacing the sun. What we see in the sky isn't a small yellow dot anymore, but a giant red ball. It's 25 times wider and 30% heavier than the sun. Even though Arcturus is a little cooler, it's still a total nightmare for Earth. The distance from our planet to the star is now 25 times less. All the water in the oceans and rivers begins to evaporate. What used to be rainforests are quickly turning into a lifeless desert. But sunsets and sunrises now look amazing. Imagine yourself on the roof of the Empire State Building, watching the sunrise. First, you see the light over the horizon. It almost blinds you because Arcturus is 110 times brighter than the sun. Then, the star gradually climbs over the surface. The thick dot on the horizon gets wider and wider. It continues to grow until the red star is everything you can see. Arcturus is now so close that you can even see storms of hot plasma on its surface. There are periodic outbursts and mass ejections. Huge amounts of matter are ejected from the surface of the star at speeds of up to 1,200 miles per second. The matter takes the form of a loop attached to the star at both ends. And you have to wear a super advanced spacesuit to be able to observe such a sunrise. Life on Earth ceased to exist long ago under these conditions, and it's going to get worse over time because every 8 days, Arcturus's brilliance increases, and soon our planet will become more like Venus. It's so close to the sun that the high temperature makes any life there impossible. Okay, let's let our planet cool down a bit and put Proxima Centauri in the center of our solar system. It's not a red giant, but a red dwarf. This star is almost 7 times smaller than the sun and almost 9 times lighter. Now our oceans and rivers are not evaporating, but freezing over. Forests and jungles are covered with snow. In about a week, there won't be a single place on Earth where the temperature is above freezing. Even plants that are used to the cold will cease to exist. They mostly feed on the sun's energy. Now, they begin to starve. But there will still be water deep beneath the ice layer. It'll be heated by the hot core of our planet. Microorganisms will still be able to survive. It's much darker on Earth too. It's like an endless twilight here. Oh, and we can barely see the moon. The thing is, it doesn't produce its own light, but reflects it from the bright sun. With Proxima Centauri instead, the moon will lose its brightness.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
But an even bigger problem would be with our orbit. The sun has a certain gravitational force, and it keeps us just in the sweet habitable zone, where we're not too hot and not too cold. Proxima Centauri's gravity is much weaker, and Earth is slowly drifting away from the star. We now run the risk of encountering asteroids flying through space, or even other planets. But the worst case scenario is if Proxima Centauri simply can't hold our planet, and we fly away into dark space. Then, you can forget about any forms of life here. Now, let's put Sirius at the center of our solar system. It's the brightest star in our night sky. It's only 70% bigger than the Sun, but almost twice as hot. So its glow is not only bright, it's sizzling. And its light is not yellow, but somewhere between blue and white. You couldn't go out in the city without sunglasses, or Sirius glasses. Still, you wouldn't want to walk the streets, where the asphalt is boiling anyway. You could literally fry eggs on the curb. Of course, by this time, all life on Earth has long since disappeared. But it's not just because of the temperature. Sirius emits enormous amounts of radiation. Our atmosphere serves as a shield against the sun. But in the case of Sirius, that shield wouldn't be enough. Now, why don't we take a more bizarre approach and make ourselves a double star system? These are two stars that revolve around a common center. And there's our Earth, safe and sound. It's all about the size and brightness of the stars. These two aren't too big, and they give off as much light as our sun. All that matters to us is that our planet is in the safe zone of the double star system. At sunrise, you first see one star appear from below the horizon, and then, a couple of minutes later, the other. The only problem is that this beauty may soon explode with enormous force. In binary systems, one star is always heavier than its companion. Sooner or later, it starts pulling matter away from the smaller star. Gradually, the bigger star just eats its neighbor. Then the big brother can reach a critical mass and explode. This explosion would be about as strong as a supernova. It would destroy our entire solar system. The light from this explosion would be visible for hundreds of light years away. And after that, there would be a huge nebula in the place of our star system. It's stardust and particles that are left from our world. Going to the realm of the crazy now, a black hole. Yes, there's one at the center of our solar system now. We know black holes are scary, mysterious objects that pull in everything in their path. But even around a black hole, there is a habitable zone. You just have to be far enough away so that it doesn't drag you down into its black abyss. Mercury and Venus would be too close to the black hole, so most likely they'd be torn apart and then head for the event horizon. This is the last stop before hitting the singularity, the heart of the black hole. There are only two problems: light and time. A black hole pulls light in instead of emitting it, so the Earth will quickly become dark and cold. And time goes slower around heavy objects. Near a black hole, 1 second can be equal to weeks or even months away in outer space. We won't feel this difference, but the entire universe around us will develop faster relative to us. Any object can become a black hole if it's compressed to a certain size. For example, the Sun can become one if it's shrunk to a width of 3.7 miles. And even the Earth, if you squeeze it to a width of 0.7 inches, it becomes a black hole. Oh, now there's some little rock lurking in the center of our solar system. It's a neutron star. It's about 18 miles wide. Some meteorites are much bigger than that, but it has a mass comparable to the Sun. So its gravitational force is about the same, and our planet's orbit is intact. But the problem is that neutron stars emit next to no visible light, so it's now permanent night on Earth. Still, it gets very hot here. When a neutron star is born, it can be several times hotter than the Sun at first, but it quickly cools down to the temperature we're used to. So there's a chance that all life on Earth hasn't yet been scorched. Another problem is that these little guys are rapidly spinning and can become pulsars. It's kind of like a powerful spotlight on two sides of a spinning star. Neutron stars also eject radiation at tremendous speeds. These rays will make our planet literally sterile. No life form would be able to exist under these conditions. And now, it's time for the biggest star ever known, Stephenson 218. This red giant is 2,150 times larger than the Sun. And if we place it at the center of our solar system, its edge will lie on Saturn's orbit. So Mercury, Venus, Earth, Mars, and Jupiter are already swallowed by the huge star. Saturn, Uranus, and Neptune are roasting like chestnuts on a fire and will soon evaporate. In fact, this could happen to our sun as well. The older it gets, the redder and bigger it becomes. It'll eventually run out of its fuel, hydrogen, and the sun will start to burn heavier elements in its core. This will cause it to expand. Then we'll see more beautiful sunsets and sunrises, but the temperature will become too high. In theory, the sun will get so big that it'll swallow the Earth, and then it'll explode in a supernova, leaving nothing of our entire solar system behind. Shiny. It was September 2nd, 1859. People all over Europe and North America woke up at night, confused and still tired. They were sure it was already morning. It was so bright outside. But when they looked out of their windows, they discovered it wasn't sunlight. The skies were lit by countless intense auroras, red, green, and purple. They were so brilliant, one could read a book as easily as in the afternoon. Auroras appeared even in the regions where they had never been witnessed before, like Cuba, the Bahamas, Jamaica, and Hawaii. Cool visual effects weren't the only thing that both mesmerized and horrified people. The most high-tech stuff at that time, telegraph wires, shorted out throughout Europe and the US. Sparks were flying from equipment, and many human operators got electric shocks. Papers and telegraph offices burst into flames. All the machines were immediately disconnected from their batteries, and still, they mysteriously kept sending broken messages. Fires, ignited by short circuits, spread over large areas. Colorful lights kept dancing overhead. All this caused panic and total confusion. Earth's inhabitants had never seen or experienced anything like that before. At that time, very few people knew that the sun was to blame for the chaos. One of them was English astronomer Richard Carrington. At about 11 a.m. on September 1st, the man was standing by a telescope in his private observatory. He was watching sunspots on the surface of the sun. Suddenly, two patches of intense white light broke out. They looked as bright as direct sunlight. At that moment, the astronomer didn't know what a terrible commotion these flares would cause. Later, it became clear that the sun had produced an epic geomagnetic storm and unleashed it at our planet's protective layer. Wave after wave of charged particles slammed into Earth's atmosphere. The planet's magnetic field wasn't powerful enough to stop them. It gave way, and the storm hit Earth, causing havoc. The phenomenon got the name of the Carrington event. So far, it's been the worst solar storm ever recorded. Good thing it happened when people didn't have advanced technologies and weren't that vulnerable to the sun's geomagnetic fury. The 1859 solar storm was 3 times more powerful than the one that happened on March 13, 1989. 3 days before it began, astronomers watched a massive eruption on the sun's surface. Within a couple of minutes, a billion-ton cloud of gas was hurled away from the star. It rushed straight toward our planet at a speed of millions of miles per hour. On Monday the 12th, the huge mass of solar plasma reached Earth's magnetic field. This storm was so fierce, it lit spectacular auroras and created underground electric currents beneath North America. These currents must have found some weaknesses in the power grid of Quebec, Canada. In less than 3 minutes, the entire city lost power. Millions of people found themselves in pitch-black streets, dark buildings, and stuck elevators. They woke up in freezing cold homes, unable to cook breakfast. The following 12-hour blackout closed businesses, airports, and schools. The Montreal Metro was also shut. In the US, hundreds of power grids started to have problems minutes after the storm hit Earth's surface. Luckily, none of these issues led to a blackout. The storm was severe enough to disrupt satellite communication systems and radio signals. Some space satellites tumbled out of control for a few hours. Lots of them had mysterious problems that went away as soon as the storm began to subside. No newspaper mentioned it, But in 2012, Earth had a close shave after narrowly missing an extreme solar storm, the most intense in the past 150 years. On July 23rd, astronomers at Space Weather Prediction Center in Colorado spotted 2 clouds of energetic particles. They erupted from the sun's surface and barreled into space. Just 19 hours later, these clouds zoomed past the spot our planet had just left. If the solar eruption had happened several days earlier, Earth would have ended up in the line of fire. So, what if a solar storm as powerful as the iconic Carrington event happened nowadays? How much more harm would it cause? Would our life get back on track after such a disaster? Before you learn the answers to these questions, let's figure out what a solar storm is. The sun is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can speed up to more than 600 miles per second. The most powerful volcanic eruptions pale in comparison with solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. When people think about danger coming from space, most of them imagine an approaching asteroid, like the one that wiped out the dinosaurs. But apparently, we should be much more worried about our good old sun. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, several days later, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have a mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the sun would damage giant transformers. Those take ages to replace, especially if hundreds or even thousands get wrecked. In some places, a failure of one power grid would make others collapse as well, creating a domino-like reaction. Picture living without electricity for a day, a month, a year. No light, no computers, no phones. Water supply systems out of order, no food in supermarkets. Plus, without electricity, it would be next to impossible to reboot the already failed power grids. A powerful solar storm would cost people $1 trillion to $2 trillion, and that's just during the first year after it happens. It would take the world another 4 to 10 years to recover. The damage to all kinds of satellites alone would reach $70 billion. Under majestic auroras, people would have to get used to a new, dramatically different lifestyle. No doubt, we'd have some kind of warning. Modern equipment all over the world and in space doesn't stop watching the sun even for a second. Once a bad solar storm happens, people would have some time to prepare, between several hours and a couple of days. And if transformers are taken offline in time, the consequences won't be so dramatic. Now, the following news might sound scary. There are also superflares. In comparison to them, our sun's bursts of radiation are small potatoes. Superflares mostly occur in young and active stars. In 2016, astronomers saw such a phenomenon. A star 1,500 light-years away from Earth produced a flare that was 10 billion times more powerful than any of those that burst from our sun. It doesn't mean we're safe here on Earth. Even our middle-aged sun knows how to produce superflares, but while young stars can have them once a week or even more often, for the sun, it's once in a few thousand years. And still, if people don't figure out how to protect the planet, just one superflare can shred our ozone layer and wipe out life on Earth.
Imagine a world of seething hot metal where iron and nickel dance in a fiery inferno. This is the inner core, the heart of our planet. But what if this very heart was changing? The latest research suggests that the Earth's inner core may be slowing down and even reversing its rotation. Is this a sign of the end of times? Will the Earth come crashing down on itself? Let's find out. Imagine you have a giant onion, and every layer represents a different layer of the Earth. The center of this onion, the part you can never reach, represents Earth's core. It's like a mysterious land that no one has ever set foot on, yet scientists have been trying to uncover its secrets for centuries. Imagine diving deep into the center of the Earth, beyond the crust, the mantle, and finally 1,800 miles below the surface where you'd reach the inner core. It's a ball of seething hot metal made up of solid iron and nickel, and it's so hot it glows a brilliant white. It's also surrounded by a liquid outer core. This mysterious place is unlike anything else on our planet. And get this, it's spinning on its own axis. The inner core is like a fire tornado that's constantly swirling, generating heat and energy from the inside out. But why is it so important to study this little piece of the Earth? Well, it's responsible for creating our magnetic field. This magnetic field is important to study because it protects us from harmful radiation from the sun. It's created by the movement of molten metal in the Earth's outer core and the spinning of the Earth. These movements generate electrical currents, which then create the magnetic field. It's like a shield that protects us and helps us keep our planet healthy and safe. But there's still so much we don't know about the inner core. For example, how did it form? Scientists believe it started to solidify about 1 billion years ago. But why did this happen? What was the trigger? Or, for example, what about the inner core's crystal structure? It's thought to be a type of iron called hexagonal close-packed iron, but we still don't know if it's actually the case. In other words, we may have many theories, but unfortunately, there's no way to confirm them, at least for now. So how do scientists study the inner core if no one can go there? They use seismology. Seismology is like a sonic scanner for the Earth. You send sound waves through the Earth and measure how they bounce back to see what's inside. That's basically how we discovered the inner core way back in the 1930s. Imagine you're listening to the sound waves with your special seismology machine. Suddenly, you hear a strange sound like a ping. It's different from the other sounds you've been hearing, and you can't explain why. You keep listening and you hear the ping again and again. You start to realize that this ping is happening every time the sound wave hits the Earth's center. You study the data more and more, and finally, you figure it out. The Earth has a solid core. This discovery was a big breakthrough and helped us better understand what's inside our planet and how it works. Right now, scientists also use something like this to study what's inside our planet. When earthquakes occur, waves travel through the Earth and bounce off different layers, including the inner core. By studying these waves, scientists can learn about the inner core's properties, such as its density and temperature. They're basically solving a mystery by piecing together tiny clues. And every new discovery brings us one step closer to understanding it. The inner core is a unique and fascinating part of our planet. It's a place where the laws of physics work in different ways than they do on the surface. And it's a place where scientists are still trying to unravel its many mysteries. And here's one of them. For some reason, the heart of our planet is about to stop spinning. A new study about this was published in Nature Geoscience. It was made by the researchers at Peking University in China. It has revealed a huge twist. The scientists found that the inner core spin rate has slowed down significantly. It's something that no one expected, but according to the results of their study, the slowing down began all the way back in 2009. And that's not all. Their results also suggest that the inner core may be reversing its rotation. That's right. This hot ball of iron and nickel that has been spinning around for millions of years may be slowing down and changing direction. It's like when a spinning top starts to slow down, except this is happening in the center of our planet. Scientists have been puzzled over the discovery for quite some time now. So, what does it all mean? And why is this happening? Well, it turns out that there might be a larger pattern at play. The scientists believe that this change in the inner core's rotation may be due to the influence of Earth's mantle and the magnetic field of Earth's outer core. The mantle and the outer core are affecting the inner core, which is causing its spinning rate to slow down and potentially change direction. Before this study, scientists thought that the inner core was spinning faster than the Earth's crust. However, this new information suggests that the inner core may be slowing down due to the gravitational effect of the Earth's mantle and the magnetic field of its outer core. But here's where it gets even more interesting. When researchers took a closer look at data stretching all the way back to the 1960s, they discovered that the rotation of Earth's inner core was consistent from the late 1970s to the early 2000s. Before that, they found that another possible slowing down or reversal event may have occurred in the early 1970s. It's like the inner core spin is like a roller coaster ride, speeding up, slowing down, and possibly reversing course over a period of time. The researchers estimate that these switches occur every 7 decades or so, which is pretty wild. But why is it happening? Unfortunately, we still have no idea. The exact reasons for why the Earth's inner core sometimes stops and starts spinning in another direction aren't yet well understood. However, scientists believe that it may be due to complex interactions between the solid inner core and the surrounding molten outer core. A lot of different things can be at play here. The changes in the temperature, pressure, and composition of the core, as well as the movement of material within the core itself, and so on. Also, as we said before, the Earth's magnetic field and the gravitational forces from the surrounding mantle might also play a role here. We need further research to fully understand the mechanisms behind the inner core's rotation changes. So, is the world ending? Fortunately, no, not just yet. While the inner core is changing direction right now, it's not the end of the world as we know it. And even though findings may seem like a huge deal, life on Earth's surface hasn't been impacted much, if at all. In fact, it's just a fascinating part of the Earth's inner workings that we're learning more about every day. So, you can say with relief, nothing cataclysmic is happening. Moreover, according to Hervoya Kalsic, a geophysicist at Australian National University, the inner core is now more in sync with the rest of the planet than a decade ago when it was spinning a bit faster. All in all, this new study has added a strange twist to the story of Earth's inner core, and scientists believe that there's still much more to discover about this mysterious place. Who knows what other secrets lie in the heart of our planet? The possibilities are endless. So let's keep researching and enjoy our time on this amazing planet.
Now, are there real-life space monsters? Well, of course, there are no huge beasts made of stars that are flying through the universe. However, there are some things in space that truly remind us of things from our nightmares. The first one is the Eagle Nebula, also known as Messier 16 or Star Queen Nebula, a wonder located in the constellation Serpens. This dazzling nebula was discovered in the 17th century and earned its nickname from the visual impression it creates. If you look at it, it resembles a giant eagle flying through the universe. It's a young star cluster, located super far away, about 5,700 light-years away from Earth. The Eagle Nebula spans a region of about 70 by 50 light-years in size. For comparison, our entire solar system is only 2 light-years long, with the distance between the Sun and Pluto being only around 5 light-hours. This enormous nebula is home to more than 8,000 stars. One of them is especially bright. It's a duo of massive stars, one about 80 times heavier than our Sun. And the nebula is actively creating new ones. Every day, the gas and dust in there are being compressed by the intense radiation and stellar winds from hot, massive stars within the cluster. This triggers the birth of new stars. And finally, in the heart of this nebula lie the iconic pillars of creation. These are vast columns of dust and gas seen in blue, red, and green hues. They serve as active stellar nurseries. The dark clouds slowly draw together to birth the stars of the future, shaping the rich and complicated materials found in the universe. Pillars of creation stretch about 4 to 5 light-years, so about twice as big as our entire solar system. The Eagle Nebula is remarkably interesting to astronomers. It's a wonderful place for us to study the star's birth and evolution. The grandeur of this place is amazing. However, it's more fascinating than frightening, unlike the following monsters. Quasars, captivating powerhouses fueled by supermassive black holes at the heart of galaxies. These black holes are millions to billions of times the Sun's mass. Matter spirals into them, forming a luminous accretion disk. Gravity within generates intense energy across the spectrum, making quasars shine brilliantly. Sometimes they can even outshine entire galaxies. These cosmic monsters have been intriguing astronomers for years. Quasars have the appearance of regular stars, but have incomparable levels of energy. Their name comes from quasi-stellar radio sources. They're radiating across the spectrum: radio waves, visible light, ultraviolet light, X-rays, and gamma rays. We've been catching their signals for many years, but first glimpsed them only in the 1960s. Quasars are one of the most ancient objects in our universe. Their light, traveling billions of light-years, helps us to learn more about the universe's early days when these monsters were aplenty. They gradually dimmed over time, so we can only imagine how brightly they looked back then. One of the most iconic of them is Quasar Colossus. It's not one monster, it's a giant group of 73 quasars. Together, they're spanning 4 billion light-years and outshine 100 million Milky Ways. Something like that is impossible for us to even imagine. Our next monster is called a pulsar. When a big star goes out of its fuel, it goes boom. What's left behind that is a neutron star, which has a mass several times that of our Sun, but crammed into a sphere as small as a city. They're super dense. Sometimes it teams up with some friend, like a companion star. If the companion shares its stuff with a neutron star, things can go wild. The extra material might make the neutron star collapse, becoming even denser. In that case, it would turn into a so-called quark star. But if it doesn't happen, the neutron star goes a different route. This immense density means that the protons and electrons in the star collapse into each other, forming a sea of neutrons, particles without an electric charge. This is when the so-called pulsars are born. Now, pulsars come with an incredible magnetic flare. These stars boast magnetic fields trillions of times more powerful than Earth's. The fun begins when this super-magnetized pulsar starts to spin. It's not a leisurely twirl. Pulsars can rotate hundreds of times per second. They're the fastest objects in the entire universe. As the pulsar whirls around, it shoots out beams of electromagnetic radiation. These beams act like lighthouses, sweeping across the universe with each rotation. If the Earth happens to be in the path of one of those beams, astronomers detect pulses of radiation. That's where the name pulsar comes from. There's someone closely related to pulsars, the zombie stars. Sometimes, even after the star reaches the end of its life and goes supernova, it doesn't fade away entirely. Some matter might remain. In that case, it transforms into a celestial zombie. These zombie stars often appear in pairs, with one star giving in to its smaller companion. It acts like a vampire, feeding on other nearby stars. It drinks up hydrogen to come back to life. When it grows to the size of a planet, it bursts into a brilliant supernova again, destroying the star it fed on. Zombie stars aren't fussy eaters. They go beyond devouring stars. One of them is in the Virgo constellation, and it doesn't just munch on stars. It gobbles up the energy and stuff from its planets. And just like actual zombies are always on the go to find more food, these stars travel through galaxies. Recently, we found another one of them in a faraway galaxy. It's been traveling and evolving over the years, getting brighter. And this show started millions of years ago, back in the age of dinosaurs. Studying them can help us better understand how space objects work in wild conditions. It also helps us reveal secrets about fundamental particles and explore the physics of superdense stellar leftovers. Now that we've met zombies, there are also cosmic vampires. Blue straggler stars defy aging by sucking life from their neighbors. They appear younger and bluer than their ancient companions because of that, confusing poor astronomers about their true age. Scientists studied 21 blue stragglers in a faraway 7 billion-year-old star cluster. That's when they made a breakthrough. They assumed that it was because of mergers or collisions. But then scientists revealed these sneaky stars as thieves, feasting on nearby stars to stay forever young. While this discovery explains most blue stragglers, a few remain mysterious, which means they probably have varied origins. Researchers plan to use the Hubble Space Telescope to detect their hidden companions and learn more about them in the future. Our final monster is an electric leviathan. In 2011, astronomers stumbled upon a colossal jet spewing out of a galaxy with a funny name, 3C303. It's 2 billion light-years away. What made this discovery truly electrifying was the electric current it carried, an insane 1,018 amps. For comparison, a regular light bulb can barely reach 1 amp. This is equivalent to 1 trillion lightning bolts. This jet, powered by a supermassive black hole at the galaxy's core, extended over 150,000 light-years, surpassing the Milky Way span. This faint galaxy, first observed in the 80s, was hidden from us for a long time. We only discovered it thanks to catching different wavelengths. Typically, jets emerge from galaxies with active supermassive black holes. Only around 10% exhibit matter-spewing jets. The secret to the record-breaking current of this little galaxy lies in the hyperactivity of its black hole. This black hole creates a super robust magnetic field, and this magnetic field creates this electrical leviathan. So not only do we find the universe's highest electrical current, but it also marked a rare opportunity to study one of these large jets. Scientists keep making their equipment better to study in more detail, so we can learn more about them in the future. Now imagine a tiny particle, like a proton, zooming towards your hand at 99.99% of the speed of light. Would you feel anything at all when it hits you? The night of October 15, 1991, A mysterious particle zoomed through space with the power of entire stars packed into tiny atoms. Its energy was 40 million times the energy of the most powerful protons ever produced in our most advanced particle accelerators, like the Large Hadron Collider. Moreover, it was incredibly fast. Its luminous tail even broke the particle speed limit. According to some scientists, any particles going that fast should eventually slow down. But this one didn't follow the rules. It just kept going just a tiny bit slower than the speed of light. The scientist, John Lindsley, was so shocked he exclaimed, "Oh my God," when he first saw this data. So that's how they named this thing, the "Oh my God" particle. Now imagine a normal particle, like a photon, traveling through space alongside this crazy racer. Well, the OMG particle has energy that's 100 quintillion times greater than those of photons. From our point of view on Earth, it would take the photon over 215,000 years to gain even the tiniest lead. If we look at its energy, it would be like a baseball thrown at almost 60 miles per hour, which would hurt if it hit your bare hand. Ow! But surprisingly, if the OMG particle aimed at you, you wouldn't feel a thing. It would simply pass through your hand. It could scatter some other particles around, but overall, the impact would be unnoticeable. And it's all because of how cosmic rays work. You see, when you're in space, there are tons of invisible particles zooming around you at incredibly high speeds. They're like tiny supercharged balls of energy. These speedy particles are called cosmic rays. Now, we normally encounter the aftermath of their atmospheric dance at sea levels. Most of the cosmic rays consist of lone protons, with just a dash of heavier particles. The higher the energy, the rarer the ray. They come from various places in the universe. They come in two flavors: galactic cosmic rays from outside our solar system and solar energetic particles emitted from the sun. We're mostly protected from them thanks to our Earth's magnetic bubble, the magnetosphere. This protective shield deflects many charged particles, including cosmic rays, away from our planet or directs them toward the polar regions. And guess what they cause there? That's right, the famous, beautiful aurora borealis. The northern lights that we often see in the Arctic and Antarctic regions of the Earth are caused by travelers from outer space. But it's not like none of them ever reach our planet. In fact, we're surrounded by cosmic rays everywhere. Thousands of these rays are dancing around us every second. And they don't just surround us, they're hitting us and passing through our bodies. However, despite that, we don't feel a thing. That's because, even though they're very energetic, they're still super small and low mass. In fact, they're so tiny that they often pass through the spaces between atoms and even inside the atoms themselves with minimal interaction. Because of all of this, we had no idea that they existed until the 1910s. A long time ago, scientists found out that the air high up in the sky has some special stuff called ionization. Ionization is when atoms or molecules gain or lose electric charges, turning into ions. In simpler terms, it's like giving a neutral thing, an atom or a molecule, a positive or negative charge. These charged particles then can do some interesting things. For example, they play a big role in electricity, allowing things like lights and electronic devices to work. In any case, scientists wanted to know where ionization comes from. They first thought it came from radioactive things in the ground. But then, in the early 1900s, a couple of scientists went up in balloons and found out that this ionization increases the higher you go. Turns out, something from space, not the sun, was making this ionization. Scientists learned a lot about them over the years, like where they come from and what they're made of. And that's how the cosmic rays were discovered. The mysterious OMG particle we've talked about was one of those cosmic rays. This particle was detected by the Fly's Eye camera in Utah in 1991, and to this day, it holds the record as the highest energy cosmic ray ever spotted. Obviously, it sparked scientists' curiosity. They wanted to find out where this supercharged particle came from and how it got its incredible speed. So they decided to investigate it. And the more they studied it, the more weird things they discovered. For example, they found out that time itself stretches out for this particle, because of how insanely fast it is. Special relativity, an idea created by Albert Einstein, says that as you speed up, strange things happen. And when you get close to that light speed zone, time starts playing tricks. For example, if the OMG particle started its journey from a spot that's 1.5 billion light-years away, for the particle, it would feel like just around 2 days have passed by the time it reaches us on Earth. Since scientists discovered this amazing oh my god particle, they've found hundreds of similar super-energetic events happening in space. But it's extremely hard to find out why they move the way they do. All the theories have their own problems and bumps. One suspect is supernovas, massive star booms with magnetic fields and energy. However, it looks like even their great energy isn't quite enough to create an OMG particle. Another top suspect was Centaurus A, a nearby active galaxy. But the evidence for this one is tricky, because the Milky Way's magnetic field alters the paths of cosmic rays. Of course, there are some crazy and exotic possibilities, like topological defects from the Big Bang or mysterious interactions within dark matter. Scientists are exploring wild ideas as well. Who knows? Maybe it's really some crazy twist of physics. High-energy astrophysics is also super helpful for studying and understanding cosmic rays. This is a field of study that explores highly energetic stuff in space, like extreme cosmic events. Scientists are interested in understanding how cosmic rays are connected to these wild events happening out there. Unfortunately, even after almost 30 years of detective work, the true origin of the OMG particles remains a mystery. Luckily, recent studies might give us some hints for the answer. In the large deserts of Utah, there's a thing called the telescope array. It's searching for superfast particles called ultra-high-energy cosmic rays. Picture a massive grid of detectors spread across the desert, keeping an eye on particles all day long. And here's what it discovered recently. There's a specific area in the Ursa Major constellation. At first, scientists didn't think much of it, but then they analyzed the data thoroughly and realized it was important. This exceptional area is a warm spot where these cosmic rays might be coming from, and it has almost 100% chance of being real. It sounds like the universe's hidden energy source, but what is this source, and why does it exist? Cosmic rays aren't just intriguing for astronomers, they also have earthly applications. In 2017, researchers used cosmic rays to discover a hidden void in the Great Pyramid of Giza. They used muon tomography, a method that examines cosmic rays penetrating solid objects, and this is how scientists unveiled the secrets of the ancient structure. Scientists also use them to look inside volcanoes. They use the same method as with pyramids. When these rays pass through a volcano, scientists can study how they move to create images of what's inside. This helps researchers figure out where different materials are in the volcano and keep an eye on any signs that it might become active. So, the more we learn about them, the more we learn about the mysteries of our universe. Scientists had to build better detectors to learn more. Thanks to all the new technology, they're learning things very rapidly. So let's see what truth they'll discover in the future. You of course know that the Earth is bathed in sunlight every day. Every day we flicker different light sources on and off, mechanically, without even thinking about it. But imagine that one day you casually flicker the lights off, fall asleep, and wake up in a completely different era. Let's see how it happened and what it has to do with light. Quantum physics is quite crazy. Classical physics is like a movie projected from start to finish, while the quantum world is like having an ability to take the remote control and manipulate scenes you're watching. Fascinating and mysterious. Let's say you have a regular light switch that can be either on or off. That's like a regular bit in computers, which can be in one of two states, 0 or 1. But in quantum computers, there's a special kind of switch, a switch called a qubit. Unlike the regular bits, a qubit can exist in multiple states at the same time. It can be both 0, 1, and all things in between, like having lights on and off simultaneously. Yeah, our universe has some weird rules. This mysterious property, called superposition, allowed us to do something incredible recently, to reverse time back. At least in a tiny experiment with quantum computers. It's the autumn of 2022. Two groups of scientists, one from Oxford and the other from Vienna, decided to conduct a weird experiment. They played around with a quantum computer to create a program that reverses time. They took a tiny electron and tried to make it go backward for a time for just a fraction of a second. It would be like breaking a billiard ball triangle, where the balls go from order to chaos and then magically reverse. But don't get too excited about time travel yet. Unfortunately, we're not sure if it's possible to recreate it in real life. The scientists cracked some numbers and found out that if we observe 10 billion localized electrons every second for the entire age of the universe, we'd only see something like this happen once. And it would only take the electron back a tiny fraction of a second. So they didn't invent a time machine. They just managed to create this simulation in quantum computers. There's another catch too. The larger the simulation, the more complex and less accurate it becomes. In our experiment, we only used 1 qubit and we managed to reverse time. In a 2-qubit setup, scientists could reverse time only in 85% of cases. And in a 3-qubit setup, it dropped to 50% with more errors. If we keep adding more qubits, we won't be able to pull this off at all. Plus, the success depends on the amount of information the system can store. For example, teleporting a person would be almost impossible because humans have so much information inside them. So, unfortunately, no time machine so far. But there are some possible uses of this discovery. Reversing qubit states in a quantum computer can help correct errors during development, sort of like a little Control-Z in real life. So, it was a tiny step to more exciting discoveries in the future. For example, recently they demonstrated another crazy little thing: send light itself back in time. Now, light isn't mere luminary. It has superpowers that we can't even imagine. The ancient Greeks believed that our eyes emitted visionary beams. Sir Isaac Newton proved them wrong hundreds of years later when he conducted his experiments with prisms. The prism broke the pure white light into a beautiful palette, and that's how we found out that light actually consists of tons of different colors. Many years later, scientists learned even more, that light is a wave. And even later, in the 20th century, we discovered the final paradox, that it's both a wave and a particle, a dual existence in one photon. And the more we learn about light, the more crazy things we find. In 2016, scientists managed to freeze the light in time. They put photons, the tiniest light particles, in ultra-cold atomic clouds. Then they managed to stop it, again, for just a moment. But the fact that it's even possible is already incredible. Then scientists got even bolder. They decided to try not only to freeze the light, but to move its direction in time. They took a special crystal and passed a photon through it, thus initiating the so-called quantum time reversal. As a result, the photon started moving into both the future and past at the same time. The science magic behind this involves two quantum principles: superposition and quantum symmetry. We already mentioned the first one. It allows tiny particles to exist in multiple states at once. Now, the second principle says that even if you flip particles around like a mirror, they'll still follow the same laws. Combining this, scientists crafted a photon that defied the usual forward march of time. But again, it's nothing super fancy yet. This time flip only works for specific particles, not entire humans. And even if it did work for us, rewinding a person even for a second would take a super long time and a lot of energy. But the fact that we can change the light's speed and make it change directions is already amazing. And scientists already see some possible applications to this. For example, Harvard researchers suggest a cool way for spacecraft to zip through space at the speed of light, by hitching a ride on supernovas. Usually, traveling to other stars takes an insane amount of energy, but these scientists have a wild idea. They think that spaceships could use natural events, like hypervelocity stars and meteors zooming from supernovas to reach super-fast speeds. It's kind of similar to how sailing ships catch the wind. Advanced civilizations could use these energy bursts to speed up their spacecraft, Imagine a cool spacecraft with solar or magnetic sails harnessing the power of a supernova boom. These sails could use the pressure of the sun's radiation to work, so that we wouldn't need any traditional engines or fuel. Plus, these sails concepts are much lighter and cheaper to launch into space compared to regular spacecraft. The team is already working on a light sail accelerated by lasers to reach 20% of the speed of light. It might not sound like a lot, but it's actually an insane speed. Their dream is to help humanity make a swift journey to Alpha Centauri in just 2 decades. Isn't it amazing how many things we can do with light, and not just in our imagination? Let's go to more practical achievements. Recently, a Canadian camouflage company called Hyperstealth Biotechnology Corporation has crafted an actual invisibility cloak. The wizardly cloak doesn't need any power source, is as thin as paper, and won't break the bank. Hyperstealth envisions a world where this material can cloak people, vehicles, ships, spacecraft, and even entire buildings. It's still in a prototype phase, but it already works pretty well. They name this incredible technology quantum stealth. It bends light in a way that can make objects disappear from sight. It can render objects nearly invisible, not only in the visible spectrum, but also in ultraviolet, infrared, shortwave infrared, and it even throws in thermal spectrum blocking for good measure. The technology works thanks to the lenticular lens, a corrugated sheet with outward curving lenses. When stacked in a specific way, these lenses refract light at various angles, creating spots that block light and conceal the object behind the material. Unfortunately, it doesn't give you a full invisibility effect, but maybe someday we'll achieve it, if we keep working on it. If you hide behind it, it will look like a little dirty or blurred glass, but you won't be visible. If you put this veil in front of your body, you'll look like a floating head. Scientific progress is in full swing. Maybe one day we'll be able to reverse time not only for little light particles, but for entire humans. Until then, let's enjoy our invisibility cloaks and stay curious.
How about playing golf? Not on Earth, but on the Moon. Let's journey back to a time 50 years ago when one astronaut turned the lunar surface into the most unusual golf course ever. Any golfer will tell you how tricky it is to avoid sand traps, but picture Alan Shepard, a NASA astronaut dealing with an entire surface that feels like super fine powder. During the Apollo 14 mission, he took a break to showcase some spacey golf skills for everyone watching from Earth. After his first shot, he excitedly made another. For him, it seemed the ball went forever and ever. Let's dial back to reality for a moment. Thanks to the research by the United States Golf Association, or USGA, we've got some numbers. They found that Alan's first moon ball traveled 24 yards, and his second stretched for 40 yards. Now, how does that compare to the average golf shots back here? In regular gravity, one usually swings to about 216 yards. Just goes to show, while we've upgraded our golf game on Earth with tech and training, the moon's low-gravity playground is a different environment altogether. Now, let's give Alan some props. Moon golf? Not as simple as you might think. His club wasn't one from your local sports store. It was a makeshift one. A moon sample collector with a club head stuck to it. Add to that the bulky spacesuit he had on. Imagine trying to swing wearing an outfit that's as stiff as cardboard. With all that gear, Alan could only muster a one-handed swing. Care to have a similar experience? Well, you might not be able to play golf on the moon anytime soon, but you can give it a shot underwater. Some say the conditions are similar. Here's where it gets even more interesting. The USGA didn't just take Alan's word on where the balls landed. They wanted to investigate. For starters, they used ultra-clear footage of the Apollo 14 mission. They also used some sharp images from NASA's special moon camera, launched in 2009. Using this imagery, they mapped out the journey of those two golf balls. Alan loved his unique golf club so much, he wanted to bring it back home. No big deal, right? Well, you see, in those days, astronauts would leave behind unnecessary items to make space for moon rocks. but not this club. So during the 70s, this interstellar golf club found a new home at the USGA Museum in New Jersey. Unlike regular golf clubs, this one had a twist. It was crafted from aluminum and Teflon. It was built to fold and fit snugly within the tight spaces of the lunar lander. How did this whole moon golf idea even pop up? Well, in 1970, golf legend Bob Hope paid a visit to NASA. Inspired by Hope's love for golf, an idea came into Shepard's head: moon golf. To turn his dream into reality, he collaborated with a golf professional and NASA's tech specialists. Together, they crafted a club that met NASA's strict safety norms. But hey, Alan didn't want this to be just a surprise stunt. Remember, traveling to the moon required very strict protocols. They couldn't just randomly have a picnic up there, you know? So, Alan made sure NASA officials agreed with this impromptu game of golf. They were initially skeptical, but eventually gave the green light after Alan passionately laid out his plan. He also promised he'd start playing if everything went smoothly on the mission. Determined to make it perfect, Alan prepped like a champ. The story goes that he'd put on his hefty spacesuit and sneak off to secret spots so he could practice. Decades later, he'd still be reflecting on his lunar escapade. He was the only golfer to ever swing on the moon. It's not just golf balls that astronauts left behind on their trips. There were actually a lot of objects left on the moon between 1969 and 1972, the year of the last moon landing. Each time you gaze up at the moon, remember that there's a cute family photo up there, some huge science gadgets, a small statue, a bunch of, well, human waste bags, and yes, some American flags. Years have passed by, and yes, technically those items are still hanging out there, though they've probably seen better days because of the harsh conditions on the moon. Some items had a special place in the astronauts' hearts and were meant to stay on the moon. But hey, leaving some stuff behind also meant they could bring back moon samples. You know the feeling. It's like when you need to make room in your suitcase for souvenirs when you're finishing a vacation. Does NASA have a complete list of things they left on the moon? Well, not really. In fact, one team tried to create a record of some of the items and reached an amazing list of 106 left there from the Apollo 11 mission alone. And that's not counting Neil Armstrong and Buzz Aldrin's famous footprints. The largest items at each landing site were mostly the sciencey stuff, like pieces of their lunar module and experiments to study the moon in depth. Then there were some beautiful tokens, like Apollo 11's plaque and a special disc with messages from leaders around the world. Some say the astronauts also took medals to remember some heroic cosmonauts, and they even left a gold olive branch, an age-old symbol of peace. Now, later moon missions had a little more fun, like Alan Shepard did with his golf game. But the award for the most heartwarming moment goes to Charlie Duke. During the Apollo 16 mission, he left a picture of his family up there. It's like he wanted them to be a part of the adventure. Although, a heads up, those photos probably didn't age well because of the moon's high exposure to the sun's radiation. There might just be an art museum up there on our satellite too. Let me explain. There is this tiny little art piece called the Moon Museum. It's a ceramic chip about the size of your nail, and it was crafted by an artist named Forrest Myers. This tiny object showcases miniature artworks from 6 talented people. Among them are even the famous Andy Warhol, the same artist known for his iconic soup cans and celebrity portraits. Forrest Myers said he wanted his mini museum to be on the moon, but there was a problem. NASA officials weren't exactly on board with the idea. However, Myers shared with the press that he handed over this art chip to an engineer working on the Apollo 12 mission. According to Myers, this engineer secretly tucked the Moon Museum onto a leg of the lunar lander. In case you haven't figured it out yet, these lunar landers don't come back to Earth after their mission. Take this with a grain of salt though, as NASA has never confirmed this story. You might wonder, why did they leave all these things? Sometimes it was about making a statement. Other times, it was purely practical. At one point, it was mentioned that during the Apollo 11 mission, for example, a decision needed to be made. the astronauts had to quickly figure out what was essential for their trip back home. They ended up creating a cleanup spot, tossing away things they didn't need anymore. Leaving things behind on the moon isn't that different from how we leave things behind on Earth, just like archaeologists study our ancient leftovers to learn about our ancestors. The stuff on the moon gives us insights about those incredible lunar missions. Some things they left had done their job, like the pole for the flag or the camera they used to broadcast those steps on the moon. Even the tools astronauts used to collect samples were left because they had more precious cargo to bring back: moon rocks. When it comes to the current state of all these items, scientists are not entirely sure. We do know that NASA's Moon Observer has spotted some of their shadows. They're still up there. The official gear was built to resist, so it might behave a bit better. But those personal items? They've probably seen better days. If you somehow fell into a black hole, it might change your future and erase your past. Well, at least theoretically. Let's start with the real world we live in. Here on planet Earth, your past can definitely define your future. But imagine you're not on Earth, but somewhere out there in the endless universe, and you stumble upon a certain type of black hole. The one that a UC Berkeley mathematician found. Not to mix it with a regular black hole, let's call this type, what about a benign black hole, huh? So here's why you need a specific black hole. Thing is, you're highly unlikely to stay alive in a regular black hole. But according to some calculations made by a postdoctoral fellow, Hinz, from UC Berkeley, this specific type of black holes we agreed to call benign ones might expand at an accelerating rate. This is what makes it possible to survive the transition from our deterministic world to a black hole, which is not deterministic. Let's imagine you survived that passage, and now you're moving towards the center of a benign black hole. It's impossible to picture what's inside, and if you, as a traveler, could actually get into a black hole, you'd never be able to communicate to the outer world what interesting things are hidden in it. But it's not what interests us for now. We need to know how to get rid of the past. Hinz, the mathematician you already know, studies non-rotating black holes that have an electric charge. The most important thing about them is that besides the event horizon, they also have the Cauchy horizon. And here's the point. The Cauchy horizon is the place where so-called determinism simply breaks down. This may sound too scientific, but let me explain it to you. The Cauchy horizon is the place where your past doesn't determine your future any longer. So, here's a mathematically proven and apparently working method of how to get rid of your past. All you need to do is get into space, find a specific black hole, make it to the center, and get to the Cauchy horizon. However, if it sounds too complicated, you can simply try not to make mistakes here on Earth. Yeah, ideas like your past gets cancelled, you have an infinite amount of options of how your future will evolve, and all that jazz sounds as unrealistic as they are appealing. Like, imagine no one knows you failed to get into college and get a degree, but from now on, you have every opportunity to do whatever you want. But only theoretically. In reality, once you get into the black hole, not that specific one we've already talked about, you're most likely to disappear once and for all. But hey, don't be sad. I'm only talking about your current physical form. It's a bit deeper than it might seem. Thing is, there's a curious principle of quantum mechanics that can be explained in a simple way. For starters, imagine that you're not a human being, but just information. You have your experience, your background, and your thoughts. All of these are the information you are. Now, let's make it even simpler. Imagine a USB drive or a book. Both of these things contain information. If you smash a USB drive that contains music and movies, it won't exist anymore in its physical form, but the information it had will never stop existing. Same with the book. If you burn it, the information it has doesn't get burned. It continues to exist, but in another form. So, this fun theory claims that even though someone passes the horizon of events, which is a point of no return before you get spaghettified, they don't stop existing. In simple words, these universe travelers still exist, but in the form of information. Now let's go back to the black holes. According to Stephen Hawking, black holes emit radiation. Radiation makes them shrink, and with time, I mean much time, a black hole can shrink so much that it eventually disappears. So what happens to the astronaut who got entangled in a black hole if it disappears? Nope, they won't be ejected from the black hole in the way they used to exist. However, they will still be ejected from there, but in the form of Hawking radiation. But it's just a theory. Right, you remember that no one knows exactly what happens in the black hole? Another theory says that what happens in the black hole doesn't really stay in the black hole. Sounds like a good alternative to Las Vegas if all the flights for the weekends have been booked. Some scientists believe that a black hole might have a portal where you can turn back time. According to this theory, there's a white hole at the end of a black hole. If you get there, you can undo things. Like, you broke your mom's favorite vase? Hop into the white hole and it'll be as good as new there. You cooked a scramble and made a fresh orange juice, but somehow lost your appetite. It's not a problem if you cook it inside a white hole. Voila! The eggs are unbroken. The oranges are uncut and juicy again. No more food waste. Alright, turning back time sounds really cool, so I guess we might actually need a black hole to help us out. If a black hole was made in a, let's say, lab, it could devour things until it grew big enough to consume the entire planet. First, it would munch on the Large Hadron Collider, which might possibly create something similar to a black hole here on Earth. Next, Geneva, where the Large Hadron Collider is located. Then the whole country of Switzerland, then Europe. At that point, it wouldn't be long before the Earth was gone too. Luckily, if a black hole did appear, it would be so small that it wouldn't be able to do anything. Black holes actually produce a lot of energy and release it, often as heat, like a furnace. That means they will fade away when they run out of fuel. Even if a stable microscopic black hole was created, it would grow so slowly that nothing would happen. Assuming that it survived long enough to absorb the tiny particles around it, a black hole of this size would take super long to get even a pound of weight. I won't be around then. But a black hole on Earth could be a great thing. Even a relatively small one may emit enough energy to completely power humanity. We're talking a lot about food, huh? Let's not forget about spaghettification. The concept is quite simple, by the way. It's all about gravity. Imagine you're playing with chewing gum. With your force, you could easily stretch it so instead of a regular piece, you can get a long and thin one. The same happens to you. Black hole force is enough to stretch you as if you were a piece of chewing gum. Gravity holds you tight on one side, which makes you stretch. You may wonder, how come you don't get spaghettified on Earth if there's gravity too? Easy peasy. It's just too weak to do that with you. If you asked a butterfly to stretch the gum, would it be able to do that? Not likely. Their tiny limbs are just too weak. Same here. The Earth is just too weak compared to a black hole. So if you were wondering whether you'll ever reach 6'6", it may never happen on Earth. But once you're in a black hole, you can go far beyond those mere 6'6 inches. Your best height moment won't last long though. If you stretch the chewing gum at one moment, it will simply tear apart. The same will happen to you because of spaghettification.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. Move over, Star Wars. Astronomers have discovered an exotic star system that puts you to shame. Did you know our solar system is a bit of a loner in the galaxy? Most stars actually have companions, and some even have multiple. For example, binary star systems are very common, consisting of two stars orbiting around a common center of mass. Usually, you can't see them with a naked eye. To an observer on Earth, they'll most likely mold together and appear to be one. For example, Alpha Centauri A and Alpha Centauri B together form a binary system. They're some of the brightest stars in their constellation and the third brightest in the night sky in general, outshined only by Sirius and Canopus. But if you look at them, they'll appear to be a single star. Although it's not always like this. There are also so-called double stars. They're located so close that they may seem like a binary system, and they can either be one or not. You can even do a little eye test. In the Big Dipper constellation, try to look for Mizar and Alcor. They're kind of hard to spot, but they're right there on the arm of the Big Dipper. Now, if you're able to see them not as one, but two, then you have good eyesight. And hey, why settle for just two stars when you can have more? Triple systems are also quite common, with three stars orbiting around each other in a delicate cosmic dance. These systems can be full of surprises because the orbits are so difficult to predict. But all this pales in comparison with the recent discovery. A few years ago, a team of researchers discovered an actual 5-star solar system. It's located 250 light-years away in the Ursa Major constellation and was discovered by the Super-WASP project. All of the stars there were formed from the same disk of dust and gas, and now they're connected in one complex gravitational dance. Now, this doesn't mean they're all incredibly close to each other. They don't do some kind of a square dance, you know. In fact, they're separated by more than the distance of Pluto's orbit around the Sun. Usually, such large systems consist of smaller ones. For example, in this case, there are 2 stars that are super far away, 2 stars that are so close that one is practically stealing the other's hydrogen, you bad boy, and one tag-along lone companion. But they all orbit around a common center of gravity. With all these interactions, it's a wonder they don't collide and create one big bright mess in the sky. But it's not surprising that each such system is more complex and rarer than the previous one. And this all raises the question, what kind of unique environments could exist in such systems? What would our life look like if we lived there? Well, let's see. Picture this. You're on a planet orbiting one of the stars in a quintuple system. It's a sunny day, and you're ready to hit the beach. As you step out of your space house, you look up at the sky and see not 1, not 2, but 5 suns shining bright like diamonds. 2 of them are super close together, almost as if they were one. Then you see the other pair, a bit further apart, each with their own glow. And finally, the loner star in the corner, just doing its own thing. It's overwhelming, to say the least. Now, you might be wondering, but what would the day-night cycle and changing of seasons look like on such a planet? Well, here things might get a little complicated. Depending on the orbits of the stars, the planet could experience pretty random daylight and darkness hours. They can even be constant or last for very long periods of time. All depends on the location of the planet. If we lived in a binary star system, things would be easier. There would be 2 distinct periods of day and night as the planet orbits around the 2 stars. But with 5 stars, their brightness and position would be constantly changing, so the day-night cycle could get extremely chaotic. Hey, I need my sleep here. On the other hand, this would make for some pretty spectacular views. We could experience several different sunrises and sunsets, each of different brightness and color per day. The changing of seasons doesn't get easier. You know how on Earth we have 4 seasons caused by the tilt of our planet's axis in relation to the Sun? Well, in a 5-star system, the locations of the stars could drive our planet insane. It's like having multiple chefs in the kitchen, all trying to cook different dishes at the same time. For example, if we're closer to star A, we experience more summer-like conditions. If we're closer to star B, things will be more chilly and wintry. And if we're located somewhere in the middle, we'll experience both summer and winter at the same time. It's like trying to juggle multiple balls at once. And this is a super simplified explanation. There are also things like the planet's orbital path, the tilt of its axis, the gravitational pull, yada yada. In short, the weather forecast will now become 10 times more unreliable. I'd hate to be the weather person on TV. That's a no-win scenario. And if that's not enough, then how about a roller coaster of radiation? The nasty solar winds and heat from multiple stars could make the conditions on our planet super harsh, rendering it uninhabitable. For example, if you're unlucky enough to live too close to the binary pair of stars, you'll feel like you're constantly stuck in a microwave. But hey, at least you wouldn't have to go to the tanning salon. And if you're too far away from the stars, it would be like living in an eternal winter wonderland. And if you're somewhere in the middle, well, imagine living in a place where you can get sunburn and frostbite on the same day. And this is just the beginning. You see, with 5 stars in the mix, there's a whole lot of gravity to go around. That's like being in a group hug with some really strong and clingy friends. The gravitational forces from the stars could tug and pull at the planet, creating tides so strong they could wash away entire cities. And don't even get me started on the earthquakes. With all that gravity, the ground beneath our feet would feel like it's constantly shaking, rattling, and rolling. On the bright side, though, at least we'd always have an excuse for being late to work. Sorry boss, I got caught in a gravity wave and ended up on the other side of the planet. You're not buying that, are you? As you can see, we'd have to try hard to adapt to such a system. All this, obviously, would create some challenges for agriculture. With multiple stars in the sky, plants would have to adapt to receiving light from different angles and intensities throughout the day. Farmers might need to create something to protect crops from excess heat and radiation. On the other hand, having multiple sources of energy from the stars is pretty awesome. Imagine fields of solar panels soaking up the rays from all 5 stars. But hey, maybe we would have been lucky and ended up on a planet where gravity and temperature changes wouldn't have bothered us so much. In that case, living in such a unique and inspiring environment doesn't sound too bad. It would have a great impact on our culture, arts, technology, and so on. With such a unique view of the cosmos, people would have a whole new canvas to work with. And just imagine, this isn't even the most complex of the systems we've discovered. For example, have you heard of AR Cassiopeia? It's a septuple star system, meaning it has 7 stars orbiting around each other. Now you might be thinking, wow, that must be a real chaos. And you're not wrong. Imagine trying to navigate a spaceship through all those gravitational fields. It's like playing a game of cosmic pinball. But all this serves as a reminder of the incredible diversity of the universe. Scientists continue to study and learn more about these rare and fascinating systems. And who knows what other mind-boggling star systems are out there, waiting to be discovered. Systems of 10, 15 stars. Nearly as many stars as there are in Hollywood. Get it? Stars, Hollywood? Okay, I agree, it's lame.
Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. A new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years, and only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation, or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas, and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the Sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the Sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the Sun and from space. But even though Saturn is protected by its magnetosphere, the Sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the Sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets.
We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the fourth planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the Red Planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is Perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero Crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero Crater itself was once a large lake. Yup, apparently there was life on Mars, and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So Perseverance went to the delta. The row wasn't easy though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig. Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero, and that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grained than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, there was more organic matter in these 2 cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, these samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, we don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out the Martian! Made you look. Look. It seems like NASA and China are each planning to send humans to Mars. Both space agencies have tentative plans to launch the first crewed missions by 2033, right when Mars and Earth are playing a game of tag. And that's not all. Other missions may happen in 2035, 2037, and beyond. The ultimate goal is to build a Mars habitat for future exploration and research. So, how are they going to do that? Well, let's find out. Now, traveling to Mars isn't as easy as hopping on a rocket. The distance between our planets can change a lot over time, ranging from around 35 million miles to 250 million miles. And even with our best technology, it takes 6 to 9 months just to get to the red planet. So, a round trip to Mars could mean spending 3 years away from Earth, dealing with extra radiation and floating around in microgravity. But NASA's Jet Propulsion Laboratory has some exciting news. Scientists have been working tirelessly to design a minimal architecture mission to Mars. They're thinking that 2033 is the perfect year to make it happen. So here's the deal. Every 15 years, the rocky planets, Venus, Mars, and Earth, align just right to create a cosmic sweet spot. The mission will make the most of this rare alignment and perform an epic gravity assist maneuver using Venus. It's like getting a boost from a planetary slingshot. We'll speed up our spacecraft and reduce the need for making our own propulsion. The report also talked about some really cool ideas, like using nuclear power for spacecraft engines and using Martian resources to make things. These technologies could make space travel faster, protect astronauts from radiation, and make it easier to live in space. They might even let us make resources and fuel right on Mars. So, this is how the plan goes down. First, we'll launch a spacecraft towards Mars. It'll spend around 30 days in high orbit, exploring and gathering valuable data. Then, it's going to head back to Earth, also swinging by Venus for a quick visit. So this whole adventure will last approximately 570 days, which is just 1.6 years. And a shorter adventure means less exposure to radiation. Now keep in mind, this mission will focus on orbiting Mars rather than landing on its surface. It's just a stepping stone, paving the way for future landing missions. Just like Apollo 8 mission orbited the Moon before Apollo 11's historic landing. Landing on Mars by 2033 might be a bit too ambitious due to funding constraints, but who knows? If all goes smoothly, it could become a reality. Now for the coolest part. We don't need fancy new technologies or vehicles for all this. We'll make use of existing ones that are already in production or being studied for the Artemis Moon program. Now let's break down our Mars mission vehicle, a big puzzle of many parts. And guess what? It was put together by a community of space enthusiasts back in 2017. That's right, it wasn't the scientists who produced it first. But now, this isn't just some fantastic idea anymore. Most of these things are already becoming a reality, being made or planned by NASA. So let's take a look at this concept. First, we have the Orion spacecraft. This is the spaceship that will take the crew to the orbit around Earth and bring them safely back home. It's like a super fancy space taxi, and it might be the most powerful taxi to ever exist. It's combined with 3 powerful propulsion stages, and we're also using a special fuel that doesn't need to be ultra cold like in the movies. Next, there's the Earth departure stage. This is an important part of the mission. It helps us make a powerful thrust that sends us on our way to Mars. Then we have Mars Transit Habitat. This is where the crew will live and hang out during their journey to Mars. Like a cozy space house with all the things they need to be comfortable. And finally, the Mars Orbit Insertion Stage. When we reach Mars, this awesome thing will help us slow down and enter its orbit smoothly. It's our maneuvering expert. Even the Mars Transit Habitat is being developed and might even be tested in a few years. That means we're on track to have the whole thing ready for our amazing Mars mission by 2033. In other words, it's all about working with what we've got and making it happen. Now, let's talk about the plan's timeline. Mid-2028, the action begins. First, we'll need to do a couple of test flights. We'll send 2 stages ahead of time to make sure we can come back to Earth safely. These stages will join together like 2 spaceships becoming best buddies. They'll orbit the red planet and then come home. To do all that, we'll use powerful rockets and 13 commercial launches. It's going to be a huge space party. Late 2032. After all that, we launched the fully assembled Mars mission vehicle to high Earth orbit. So far, this is an empty vehicle that awaits astronauts. If all is good, then it'll be ready for the final check. March 2033. Time for our brave crew and their Orion spacecraft to join the party. We launch them and they dock with the Mars mission vehicle in Earth's orbit. They'll make sure the whole lot is just right before we head to Mars. Flexibility is important, so we can adjust our plans if needed. April 2033. Everyone's ready for the adventure. We perform a powerful burn, like a big push that sends us on our way to Mars. The crew will travel for about 200 days. November 2033. Finally, the crew reaches the red planet. Once they're in Mars orbit, they'll spend about 30 days exploring and doing awesome space stuff. Mars will be our playground. When it's time to return home, they'll say goodbye to the stage that helped them get into Mars orbit. Then their vehicle will meet up with the 2 stages we sent ahead. Remember these space buddies? And after that, it will take us about 340 days for the crew to come back to Earth. This is where we'll use the gravity of Venus to slingshot around the Sun. To keep the equipment and crew at the right temperature, we'll have a sunshade that will protect us from the Sun's heat since we'll be really close to it. In the end, Orion will re-enter Earth's atmosphere and splash down in the water. What a heroic ending! And this would be just the beginning. Our awesome team has another plan for the bravest adventurers out there. It's called the Conjunction-class long-stay mission. It launches in April 2033 and lasts a long time, 950 days. That's more than 2.5 years, with 550 days spent in Mars orbit. It requires fewer launches from Earth, but has some different challenges, like spending more time in microgravity and dealing with increased radiation. So we'll need some real space heroes for this one. But of course, there are some major hurdles to overcome before we can make all this happen. Experts closely looked at NASA's Journey to Mars program and found that the plan needs some serious changes. There are a few high-risk areas, like life support systems for long missions, using solar power for propulsion, making oxygen on Mars, and so on. They're also worried about timelines, funding, and many other things. So, according to them, sticking to a deadline of 2033 might be impossible with the current plans and budgets. Even aiming for 2035 carries significant risks and possible delays. But hey, space exploration has never been easy, right? With realistic determination, anything is possible. Most likely, the idea of sending people to Mars will be realized before 2040. NASA is working on finishing the plan and details to make this possible. So, even though we still have some tough nuts to crack before we can make it a reality, the dream of sending humans to Mars is exciting. It's a thrilling adventure full of challenges, discoveries, and the spirit of human exploration. So, let's show the universe what we're made of. And that would be mostly carbon.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the Moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next